You might think high-tech telescopes let us see every inch of the moon, but that's not true. At our satellite's south pole lie giant craters untouched by sunlight for eons, stuck in pitch black, colder than Pluto, and almost impossible to explore. However, maybe we have to if we want to explore space. Because the darkness hides some must-have resources that will make life and long-distance travel in space possible. Yes, we're talking about water locked up as tiny crystals in the lunar soil. Now, water in space is always good news. You've probably heard that scientists are also obsessed with finding it on Mars. If the red planet has any type of water below its surface, it raises the exciting possibility that life might have existed there. Even microbes would be the biggest discovery in human history. That's why rovers are poking around Martian craters and drilling into the soil like some very dedicated space gardeners. But as incredible as water on Mars would be, water on the Moon might be even more valuable to us in the short term. The reasons are simple: the distance and the gravity of the Moon. We can reach our satellite in 3 days. That's almost nothing. It takes at least 7 days to reach New York from London via a cruise ship. But more important than the length of the trip is the possibility of using the Moon as a pit stop. Stop, refuel, and relaunch so we can resume exploration. The gravity on the Moon is only 1/6 as strong as Earth's. That's not just useful for endlessly entertaining yourself by jumping around. This difference means that launching rockets from our satellite is much easier compared to launching them from Earth, which requires a tremendous amount of fuel just to break free from the atmosphere. For example, the Saturn V rocket, which took astronauts to the Moon during the Apollo missions, was made up of more than 90% fuel just to get off the ground. On the Moon, however, it's much easier to launch a rocket. That means that we could carry heavier loads with less fuel. It's like being able to take a bigger suitcase on your trip. If we can find and use ice on the Moon to create rocket fuel, it would turn our satellite into a practical and affordable stop for exploring the solar system. Not to mention that by applying some basic chemistry, we could extract oxygen from water and use it for breathing or rocket engines. Also, astronauts would need water to drink and grow crops on the lunar base. So, what do we know about the latest discoveries? For a long time, scientists thought the Moon was completely dry. But in 2009, NASA basically crashed a rocket into a crater. It caused an explosion of ice and vapor, like fireworks, and finally confirmed that the Moon had some kind of water. But how much? Well, enough to matter. The data suggests there could be hundreds of millions of tons of water ice locked up in the Moon's polar regions. Some estimates roughly say 1.3 trillion pounds. That's about the same weight as 460 million cars. Not exactly lakes, but still a lot. And there still could be more. This water could also contribute to uncovering cool scientific secrets. The ice is ancient, which makes it like a time capsule from the early days of the solar system. Studying those frozen molecules might tell us not only how water got to the Moon, but also how it appeared on Earth. Anyway, what's all that water doing on the Moon? How did it get there? Scientists assume that some of it probably hitched a ride on comets and asteroids billions of years ago. Many of those space rocks carried ice, and some of that water ended up in the polar regions. Another source could be the way solar wind interacts with the lunar surface. In any case, however this ice appeared on the Moon, the real trick is where it ended up, inside its polar craters. And while we can find the ice not only in the craters at the South Pole, that's where the largest, most stable reserves are believed to be. Some of those craters are enormous. One of the most famous is called the Shackleton crater, and it's over 13 miles wide and more than 2 miles deep. That's almost twice as deep as the Grand Canyon. The Moon barely tilts on its axis, only about 1 degree, so the Sun never peaks over the rims of those deep polar pits. The temperatures dip to around -400 degrees Fahrenheit there. Any water or chemicals trapped in that frozen dirt just stay there, locked away like in a freezer. Something really cool is that at the South Pole, you have parts that are stuck in the perpetual darkness. But some nearby mountain ridges get almost non-stop sunlight. Scientists call them the peaks of eternal light. They are perfect for setting up solar panels, while still being close enough to access the icy treasures hidden below. The poles of the moon are the only places in our solar system we know of where perpetual day and night exist side by side. But the eternal night isn't just fascinating, it's dangerous. The terrain out there is absolutely unforgiving. We can't even simulate something like that on Earth. We don't even know what it looks like from the inside. It's worse than exploring the northernmost part of Antarctica while wearing a blindfold. So now that we know this, is that potential water even obtainable? That question is probably worth several trillions of dollars. Yes, there's water over there, but getting to it won't be like scooping ice cream from a bowl. What we're really talking about are microscopic ice crystals mixed into lunar dust. To make use of it, machines would need to dig and heat up the soil, then capture the vapor before it escapes back into space. And then there's freezing. Even assuming a human or rover could safely reach the bottom of a crater, it'd be almost impossible to navigate. Batteries and equipment probably wouldn't last, and it's impossible to use solar panels or electronics down there. They'd freeze in minutes. However, NASA's Lunar Reconnaissance Orbiter uses all kinds of radars and sensors to sniff out what the crater looks like inside. And now there's an even sharper tool, shadow cam. A camera so sensitive it can capture details in light 100 times dimmer than what our eyes can see. Basically, the ultimate night vision device. With it, we can finally map those pits without even setting foot there. That's why engineers are thinking up all sorts of clever solutions. Some concepts involve nuclear-powered rovers with headlights strong enough to carve through the dark. Others want robots that rappel down crater walls or hop across the floor like pogo sticks. There are even ideas for drills that could melt frozen soil and trap water vapor like condensation on a cold soda can. The silver lining is that this water isn't going anywhere. Until we improve our technology, the supply will wait for us. That being said, space agencies are already making advancements. In fact, more than half a dozen new missions are lined up over the next few years. NASA's Artemis program is getting ready to send astronauts back around the moon and then down to the South Pole. China's Chang'e 7 is planning to check out those dark craters. And private companies like Firefly and Blue Origin are gearing up to deliver equipment and experiments. Now, here's a bonus, lesser-known fun fact. The moon smells. When Apollo astronauts brought lunar dust into their landers, it mixed with the oxygen inside and ended up smelling pretty strong. They said it was like burnt gunpowder or fireworks. Lunar dust has nothing to do with gunpowder, but its particles are highly reactive. After sitting in space for billions of years, they reacted instantly with oxygen in the cabin, creating that smoky odor. Future explorers are definitely going to notice that smell too, since lunar dust tends to stick to everything. Let's hope that, aside from everything else, scientists will work out air fresheners for the moon base.
This is a typical crater on the moon. It's here because, once upon a time, an asteroid crashed right into it. Yep, a lunar crater forms when an asteroid, meteoroid, or a comet slams into the moon's surface. And as you can see, it's happened a lot. But one crater formed in a very different way. But then, how did it form? Well, let's rewind a bit. There's a widely accepted hypothesis that the moon itself is a product of collision, just like all these craters. But that collision was way tougher. It happened over 4.5 billion years ago when a huge Mars-sized planet called Theia crashed into Earth. That event threw a bunch of debris into orbit. Eventually, it came together to form the moon. Now, for a while after that, the moon was basically a giant ball of lava. But because the early moon was very close to Earth, our planet's gravity kept squeezing it, making it even hotter. In the end, though, the moon drifted farther away, cooled down, and formed a rocky crust. Now, moving on, about 4.3 billion years ago, an asteroid the size of a small country, like Nepal, way bigger than the one that wiped out the dinosaurs, slammed into the moon's far side. It left an enormous crater called the South Pole Aitken Basin. It's up to 5 miles deep and about 1,500 miles wide. For comparison, that's roughly the distance from New York to Dallas and deep enough to swallow Mount Everest. Now, scientists think that impact may have dug up and scattered some ancient stuff from deep inside the moon, a mixture of materials nicknamed creep, short for potassium, rare earth elements, and phosphorus. It's like a chemical time capsule from when the moon was still a lava ocean. Now, you want to know the reason why this area could be even more scientifically interesting than we realized? You see, until recently, researchers believed the asteroid came from the south, slamming upward and spreading a bunch of radioactive material, that very creep, around the crater's northern rim. But after looking closer, scientists realized the impact actually came from the north, which means all that valuable creep ended up on the southern edge instead. And guess what? NASA's Artemis 3 mission happens to be targeting that exact southern region. Researchers started questioning the old southern impact theory when they compared the moon's crater with others across the solar system, mainly Mars's Hellas Basin and Pluto's Sputnik Basin. Here they are. See? All three have this bizarre teardrop or avocado shape, wide on one side and pointy on the other. And exactly that pointy end usually shows which direction the asteroid came from. In the case of the South Pole Aitken Basin, that means the asteroid hit from the north, not from the south. To confirm it, scientists dug into old data from NASA's Lunar Prospector mission. It orbited the moon in 1998 to 1999. That spacecraft measured radioactive elements on the surface and found high concentrations of thorium, a key part of creep, around the basin's southwestern rim. Now, the Artemis 3 mission is NASA's big plan to put humans back on the moon for the first time since 1972. If everything goes according to schedule, the launch is set for mid-2027, right after Artemis 2 wraps up. See, Artemis 2, which is supposed to launch before April 2026, will be sort of a dress rehearsal. Astronauts will orbit the moon without landing just to make sure that all the systems work smoothly, a cosmic test drive. Artemis 3 is where things are going to get real. The astronauts are expected to land near the moon's south pole, in one of 9 possible locations NASA has scouted out. The only problem is timing. Artemis 3 has already been delayed a few times, and so has Artemis 2. Artemis 1 launched in 2022. It was an uncrewed test flight that went around the moon and came back just fine. So, next up is Artemis 2, which will take real astronauts further into space. Then comes Artemis 3, the big one. Astronauts are supposed to hang out on the lunar surface for about a week doing sciencey stuff before heading home. After that, Artemis 4 and 5 will build and expand a new mini space station orbiting the moon. It's called Gateway. Think of it as a pit stop in space. Astronauts can dock there, live for short missions, do experiments, and prepare for landings. NASA's building it with help from the European Space Agency, Japan, and a few others. The astronauts are going to travel in the Orion spacecraft, launched by NASA's Space Launch System, a massive rocket taller than the Statue of Liberty and strong enough to fling people to the moon. To actually land, they'll use the Human Landing System. SpaceX's Starship is supposed to take the first cruise down to the moon's surface once it proves it can land safely. In the long run, NASA's not going to stop at the moon. The big goal is Moon to Mars. Hopefully, we can use everything we learned from Artemis to build a lunar base and eventually send humans all the way to Mars. And who knows? Maybe when people land on the moon, they'll be able to figure out another unsolved mystery: flickers, glows, or beams of light that sometimes illuminate our satellite. Let's dig deeper into this mystery, shall we? On the night of April 19th, 1787. Astronomer William Herschel spotted something weird, a bright light glowing on the dark part of the new moon. It shone for hours and was almost as bright as the Orion Nebula. What he saw probably was what scientists now call a transient lunar phenomenon, or TLP. Basically, quick little flashes or color changes on the moon's surface. TLPs can look like glowing patches, reddish or purple spots, or even hazy clouds that suddenly appear and fade away. Over the last 2,000 years, people have recorded around 3,000 of these strange moon flashes, using telescopes, cameras, or sometimes just their own sharp eyes. So, what's really going on up there? Well, there's no single answer. Lots of different things can cause TLPs, from meteor impacts to gas releases or even electrical activity. The length of the flash, which can last anywhere from a split second to several hours, gives scientists clues about what's behind each mysterious lunar light show. The super short flashes lasting less than a minute are most likely caused by tiny space rocks crashing into the moon. Even a meteoroid, the weight of a billiard ball, can hit the lunar surface hard enough to make it glow for a split second. The heat from the impact makes rocks shine and then quickly fade as they cool down. For a long time, scientists suspected these quick flashes were caused by meteor hits, but they couldn't prove it until the 1990s, when high-speed cameras finally became common in lunar research. Even then, it wasn't easy to confirm. Short flashes could have just been camera glitches or electric noise. The only way to be sure was to catch the same flash from two or more places at once. Well, that happened for the first time during the Leonid meteor shower in 1999, when scientists recorded real impact flashes on the moon. Later, we got more proof that the moon was often peppered with space rocks. While the flashes seem to cluster in certain areas, like Oceanus Procellarum, one of the moon's big dark plains, that's likely just because of where scientists have focused their cameras. A 2024 study showed that meteoroids actually hit the moon evenly everywhere. Now, flashes that last a few minutes are probably caused by something totally different: gas leaks from inside the moon itself. Studies from 2008 and 9 found that when gas like radon builds up under the lunar surface, it can suddenly burst out. Hey, I know how that feels. And when this radioactive gas escapes and decays, it gives off a faint glow we can see from Earth. Interestingly, those glowing spots often line up with areas where scientists have already found higher radon levels. Then, there are the long-haul lights. They stick around for hours, like the bright glow William Herschel saw back in 1787. A 2012 study suggested those could actually be caused by solar wind, a stream of charged particles coming from the sun. When that solar wind hits lunar dust, it can charge up the particles and toss them into the air, well, into space, creating massive dust clouds up to 60 miles high. These floating clouds might bend or reflect light from stars or planets nearby, making it look like the moon itself is glowing. So hopefully, we'll get the answers once the Artemis mission lands and starts its exploration. Hey, I can hardly wait.
Remember that asteroid that wiped dinosaurs off the face of the Earth? Brace yourself. We might witness a similar scenario in our lifetimes. And this time, the consequences might even be more catastrophic. There's just one tiny difference. This new asteroid is likely to smack into the moon. No, this is not a sci-fi scenario anymore. There's this asteroid called 2024 YR4 that scientists say has about a 4% chance of hitting the moon in 2032. So what do we do? Try to gently shove it off course or blow it up? A bunch of researchers, including people from NASA, dug into this and suggested several options. Their worry is real. If that rock hits the moon, it could kick up a massive cloud of debris, and this cloud could spike to as much as 1,000 times normal levels for a few days. That's not just messy, it could endanger astronauts and satellites in low Earth orbit. One obvious idea is to nudge the asteroid so it misses the moon. Another is a full-on breakup. Basically, a deliberate explosion. Experts use a clever term to describe it, a robust disruption. But nuking an asteroid is totally untested. Nobody has ever done it before, and it carries huge risks. You could create a bunch of smaller but more dangerous fragments, or do something unexpected that can make things worse. In any case, the idea is out there for scientists to chew on. Now here's the backstory. 2024 YR4 was first spotted on December 27, 2024, and reported to the Minor Planet Center. That's the official hub that tracks all new asteroids and comets. Pretty soon, it showed up on NASA's Century Impact Risk Table, which is like the agency's watch list for any asteroid that could potentially hit Earth. For a little while, things looked sketchy. Out of 37,000 plus known large asteroids, YR4 was the only one with a real chance of smacking into Earth anytime soon. Its odds even climbed to a record 3.1%.
That might not sound like much to such amateurs as me and you, but in space terms, that's huge. Scientists were really paying attention. Luckily, after a few more months of better tracking and sharper observations, they nailed down the asteroid's orbit more precisely. Turns out its path isn't taking it anywhere near us after all. Its chance of hitting Earth has dropped so low it's basically zero now. So, we can breathe out and relax. Earth is safe. But the moon? Maybe not. And that's why researchers are now debating whether to blow the thing up before it ever gets close. The thing is, asteroid 2024 YR4 is pretty big. Based on what the James Webb Space Telescope saw, it's about 220 feet long, roughly the size of a 20-story building. Not exactly a pebble, I'd say. At first, NASA thought there was only around a 1.7% chance that YR4 would crash into the moon. But then, the Webb telescope checked again in March, and that number jumped to 3.8% right away. By May, it climbed once again. It was already sitting at about 4.3%. In other words, the more they looked, the more likely it seemed that this space rock might actually hit our natural satellite. On the bright side, these new observations helped NASA figure out where exactly the asteroid would be on December 22, 2032, with about 20% better accuracy. Now, if the asteroid really did smash into the moon, NASA says it wouldn't mess with its orbit or make it wobble or anything dramatic like that. And this is a very big but a hit from something that large would kick up a ton of debris. And that flying space junk could become a real problem for satellites orbiting Earth, or even for astronauts on the International Space Station. That sounds alarming enough. That's why the story might take a turn straight out of a sci-fi movie. Scientists are seriously considering blowing the asteroid up. But unlike in a movie, this isn't about saving Earth this time. The most extreme idea is to launch a bunch of nuclear explosives at the asteroid before it reaches the moon. The thinking is, if they can blow it to pieces while it's still far away, the debris will scatter safely into space instead of causing problems near Earth. But of course, there's the catch. While scientists know roughly how big YR4 is, they don't know exactly how much it weighs. And that's a huge problem. Without knowing its mass, space agencies can't design a precise mission to knock it off course. In theory, they could send out a reconnaissance spacecraft first, something to get close to the asteroid, measure it up, and figure out the best way to push it away. But researchers say there just isn't enough time. By the time we'd collect all the needed data and build the right hardware, it'd be too late to intercept the asteroid before the 2032 impact window. So instead of a gentle space nudge, some experts suggest going full Armageddon-style, that very robust disruption. Translated into human, it's blasting the asteroid apart with nuclear explosions. Sure enough, this idea comes with a massive risk. What if the explosion accidentally changes the asteroid's path and sends some fragments toward Earth? The researchers admit it's a possibility, but still think nuking it could be the most practical solution, given the circumstances. If the mission ever happens, it would need to launch sometime between 2029 and late 2031. This would give it just enough time to reach and intercept the asteroid before it gets too close to the moon. Now, nuking space rocks might sound over the top, but NASA actually has some experience with asteroid defense. Back in 2022, they pulled off something groundbreaking with their Double Asteroid Redirection Test, or DART. That mission was all about proving that humans could physically change an asteroid's path without using explosives. NASA launched a small spacecraft in November 2021, and after almost a year of travel, it crashed head-on into a tiny asteroid named Dimorphos at about 14,000 miles per hour. The idea was simple. If you hit an asteroid hard enough, you can slightly change its orbit, just enough to make it miss Earth someday. And it actually worked. The test showed that even a relatively small spacecraft could make a serious difference. Now, the European Space Agency wants to double-check exactly how much of an effect that crash had. In October 2024, they launched a follow-up spacecraft called Hera from Florida's Cape Canaveral Space Force Station. Hera is on a 2-year journey to reach Dimorphos and its bigger partner asteroid, Didymos. By October 2026, Hera will enter orbit around the asteroid pair and start collecting data, basically checking NASA's math. ESA scientists hope that once they analyze the impact site, they'll find out how effective DART was at changing the asteroid's trajectory. If it turns out that kinetic impact, aka smashing a spacecraft into an asteroid, works well enough, future missions might use that technique again. Maybe even for YR4, if it ever becomes a real threat. But if it doesn't, that's when the nuclear backup plan might come off the shelf. Either way, scientists are making sure that if a space rock ever threatens Earth or the Moon, humanity will have more than just a Hollywood script to rely on. By the way, people at NASA run what-if asteroid exercises every 2 years to get scientists, state agencies, and international experts on the same page. During such asteroid drills, experts pretend that a giant space rock is heading our way. Then they work through all the tricky questions they can come up with, like how big is it, where might it hit, what should we do? It's like a massive brainstorming session to make sure that if this ever happens, we won't be starting from scratch. To make these scenarios feel as real as possible, NASA's Center for Near-Earth Object Studies gets involved. These are the folks who track real asteroids and calculate their orbits. So they simulate months of asteroid observations, complete with uncertainties about its size, trajectory, and potential impact zones. No one knows exactly how big the asteroid is or where it can hit. It's the kind of uncertainty that makes decision-making way harder, just like it would be in real life.
In 2024, Earth was joined by a mini-moon that orbited around our planet for 2 months. It hung around, made a few laps, and then, like every polite guest, it left. It went back to resume its trip around the Sun. However, astronomers now say another rock has been tagging along with Earth not for weeks, but for 6 decades. It's rare and strange, now being classified as a quasi-moon. But what exactly does that mean? Is it like a backup satellite? Unlike our cool and mysterious moon that illuminates our nights and affects werewolves, a quasi-moon doesn't circle Earth. Instead, it orbits the Sun, but it does so almost in perfect sync with us, like a runner doing a marathon with you that keeps a similar pace. Space only seems calm. It's actually pretty chaotic. The Sun, the Moon, Earth, and even other planets are constantly tugging on each other and smaller objects like these rocks. Most asteroids can't hold this delicate balance for long. They either get nudged into a new orbit, pulled closer to Earth, or flung out into the vast reaches of space. That's why we're lucky to spot more than 1 or 2 at a time. Most just can't keep the balance. They belong to a bigger family called co-orbitals. In fact, astronomers group them into a few types based on how they move relative to Earth. But unlike the real moon, that's been our companion since the very beginning, these visitors don't stick around forever. Some hang with us for a few decades, others for centuries, before drifting away because the gravity of some other space object. Kinda like a dog running to your neighbor after smelling bacon. One other thing about quasi-moons is their size. Most are tiny, building-sized or even smaller. They're also so dim that they can hide in plain sight among stars. Still, they're important. By studying them, astronomers learn how small near-Earth objects move and how long they can stay caught in Earth's gravity. Quasi-moons are closer than other asteroids on the same path, and it would be easier to reach them. One day, they might be used as stepping stones in space exploration. Earth has had a few of these tag-alongs before. One of the most famous is 2016 HO3, nicknamed Earth's Constant Companion. It's only about 300 feet wide, but it's been keeping pace with us for nearly a century. Researchers say it might keep up for centuries more. But what about the most recently discovered one? The researchers named it 2025 PN7. Like we said, it's already been with us for 60 years and will likely stay for around 68 more. For a long time, it remained undiscovered because of its tiny size, only about 62 feet across, which is about the length of a bowling lane. This also answers the question of whether you could see it yourself if you knew where to look. Its backstory is a bit of a mystery. Astronomers haven't figured out its composition yet. Right now, all we know for sure is its trajectory. Some quasi-moons are just near-Earth asteroids that fell into a perfect orbit. Others seem like they could be chunks of the moon itself. For instance, there's another quasi-moon named Kamo'olioa that reflects light in almost the same way as the lunar rocks we brought back during the Apollo missions. Because of that, some researchers think it might actually be leftover from a huge impact that happened long ago. There's also 2024 PT5, a temporary mini-moon from the end of last year. Tests showed that its surface looks like lunar basalt, suggesting it probably came from the moon. So how do these quasi-moons pull off their cosmic balancing act? That's because it's just an orbital illusion. Remember, PN7, like other quasi-moons, isn't actually circling our planet. To us, it looks like the rock is scribbling lazy loops around Earth's path, like doodles in space. Yet it never lags too much or gets too far. Astronomers call this a one-to-one resonance. In plain English, it makes a lap around the sun every time Earth does. Another fun question. If these fake moons are so close to Earth, why don't we just pull them in with our gravity? Especially since they're tiny and seem so near. That's because even though they belong to a group called near-Earth objects, quasi-moons are not that close. Our moon is hanging out about 239,000 miles away. These companions, though, are flying around the sun millions of miles out, way beyond Earth's gravitational pull. That pull exists within an area called the Hill sphere, which is where Earth's gravity is stronger than the sun's. Think of Earth's gravity as a bubble with a radius of about 1,000,000 miles. Anything inside can get caught, like the real moon. Step outside and the sun takes over. This is exactly what happened to PT5, which was our legit satellite for 2 months in 2024. It dipped inside the Hill sphere and Earth's gravity took over. Once it happened, this object became known as a mini-moon. But because it was small and moving fast, it eventually slipped back out of that bubble, and the sun's gravity pulled it away again. One other type of co-orbiter, aside from quasi-moons and mini-moons, is the so-called horseshoe orbiters. These space rocks don't stray far, but from Earth's point of view, they seem to swing ahead of us, slow down, then drift back behind, and repeat. It's like an undercover cop tailing you in traffic, but constantly switching lanes and doubling back so you don't notice the pattern. If you trace their motion from Earth, over time, it forms a giant horseshoe shape, hence the name. And these are just the main co-orbiters. There are actually more. Way ahead of us and way behind us in space, there are a few quirky rocks called Trojans. They're not just following right next to Earth like quasi-moons do. Instead, they found 2 special hiding spots. One 60 degrees in front of us and one 60 degrees behind. Imagine riding your bike and having a friend way ahead of you and another one way behind. both keeping the same speed. That's what Trojans do. Those spots are called Lagrange points, cozy hangout regions where the gravitational pulls from Earth and the Sun balance out perfectly. When they find themselves in one of those areas, they could be staying there for millions of years without drifting away. Jupiter, for example, has tons of these freeloaders. Earth has only a few. Then there are tadpole orbiters. Instead of sitting perfectly still in a Lagrange point, they wobble around it in lazy bean-shaped loops. And if that's not confusing and overwhelming enough, there are also jumping Trojans, the indecisive ones. These guys can't pick a side. They'll spend a few thousand years staying in the front hammock, then slowly drift to one behind us and back again. Rare, weird, and kind of awesome. So even though Earth only has one big moon in the sky, we've actually got a whole gang of intrusive space tagalongs. Some loop, some trail, some hide in the corners. Now let's recap the superpowers of our moon. It can affect tides, slow down Earth's rotation, and even help stabilize our planet's tilt. Without the moon, our days would be shorter, our nights darker, and the seasons way more chaotic. The moon also acts like a giant shield, sweeping up or deflecting some space rocks that might otherwise smack into Earth. And let's not forget its cultural influence. It's been inspiring myths, calendars, love songs, and millions of melancholic walks in the middle of the night. Fake moons can't compete. However, they are important in their own way. Each new quasi-moon we find helps us understand how these little rocks survive in all that cosmic chaos. By learning about our environment, we also learn something about ourselves. They sharpen our detection skills and help us improve our models. So while they'll never shine in the night sky, they still play a quiet role in helping us understand our quirky cosmic neighborhood.
Well, guess what? Earth has not one, but 7 moons. At least 7. There might be more. And this knowledge changes the whole picture of the world, doesn't it? Does it mean we're going to colonize not 1, but 7 space bodies and have 7 lunar bases? Will we have a choice on which natural satellite to spend our space vacation in the future? Well, here's the thing. These extra moons are kind of different. They're called mini-moons. Now, there's no official definition for a mini-moon because, of course, scientists can't agree on anything. But the general idea is it's a space rock that gets temporarily stuck in Earth's gravity, does at least one full loop around us, and at some point swings in pretty close, like within 4 moon distances close. Basically, if it gets close enough to freak out astronomers, it counts. Our Earth gets these tiny moons from time to time. They swing by, hang out for a bit, and then head out to orbit the Sun. Every now and then, chunks of space debris get caught by Earth's gravity and starts orbiting us for a while, just like they're crashing on our couch before hitting the road again, sort of cosmic speed dating. Scientists thought that most of these mini-moons came from the asteroid belt, a giant pile of space rubble between Mars and Jupiter. But some recent discoveries are kind of throwing a wrench in that. It turns out that some of these tiny moons might actually be pieces of our own moon. One famous example, back in 2016, a telescope in Hawaii spotted a weird little object hanging out near Earth. They named it Kame'o'olea, which to me sounds like a cool vacation spot. But it's really a 328-foot wide space rock that orbits the Sun in sync with us. Later studies showed it probably broke off the Moon between 1 and 10 million years ago, I wasn't around then, when something massive slammed into it and made the Giordano Bruno crater. And just recently, another object popped up, 2024 PT5. And guess what? It also looks a lot more like a piece of the Moon than your typical asteroid. Naturally, researchers couldn't resist running the math. One of them, Robert Jedicke, also known as the guy who's basically the mini-moon expert, and his team did several simulations to figure out how often moon chunks might end up orbiting Earth. Turns out, a lot of that debris can actually get caught by Earth's gravity, at least for a little while, and about 20% of it could become legit mini-moons. Now, the best guess is around 6 or 7 little lunar-borne space pebbles might be orbiting Earth right now. Not forever, though. These guys have commitment issues. The average mini-moon sticks around for about 9 months before piecing out. And because new debris is always drifting into Earth's neighborhood, the squad keeps refreshing. But here's the thing. These numbers are super shaky. Jedicke literally said the uncertainty is ginormous, and I'm doing air quotes, which is the most sciencey way of saying, we're guessing here. There are just too many unknowns, like how big the moon explosions are, how fast the pieces fly, and whether our telescopes are even good enough to see the tiny stuff. So yeah, the prediction might be totally wrong, but that's science for you. You make a guess, someone proves you wrong later, and we all get smarter in the end. In any case, little mini-moons are super annoying to spot. They're usually the size of a car or an SUV, somewhere between 3 and 7 feet wide. It might sound big when you're parallel parking, but in space terms, that's basically a breadcrumb. But an even bigger problem is that they're tiny and fast. For us to see them, they have to swing pretty close to Earth so they reflect enough light. But when they're that close, they're also zipping across the sky like they're late for something, which makes them really tricky to catch even with fancy telescopes. That's one of the things that makes scientists worry about mini-moons. What if one of them eventually ends up in Earth's atmosphere? Then it could be the Chelyabinsk event number 2. You see, it was a quiet morning in Chelyabinsk until it wasn't. There was a flash of light so bright it outshone the sun, followed by a deafening sonic shock that rattled the skies and shattered reality, along with a few thousand windows. It happened on February 15, 2013. Without warning, a space rock the size of a house burst into Earth's atmosphere at over 11 miles per second. About 14 miles above the ground, it detonated mid-air, unleashing an immense amount of power. Glass rained down in homes, schools, offices. Over 1,600 people were injured, most of them by flying shards. And it wasn't even a big asteroid, just a cosmic pebble compared to the ones lurking out there. Luckily, according to Jedicke, modern sky surveys are surprisingly good at spotting stuff that small, even from millions of miles away. But there's a catch. These things move so fast they don't show up as dots in images like normal space objects. They leave streaks, and computers intensely dislike streaks. Those motion trails are harder for algorithms to recognize, so these tiny moons often just slip by unnoticed. Luckily, it's not all doom and gloom. The researchers point out that we did manage to spot one, 2020 CD3, even though it was only visible on 2 out of 1,000 possible nights. That's like finding a needle in a haystack while the haystack is spinning. But once we know where a mini-moon is, it's way easier to track it. And here's where things get exciting. Those tiny visitors might actually be useful. Since they come so close to Earth, they'd be way cheaper to reach than flying all the way to the asteroid belt. So space companies might one day try to snag one and mine it for minerals and stuff. Scientifically, mini-moons are also kind of a big deal. They could help us understand how the solar system was built and how it's still changing. Studying how chunks of the moon got blasted off and turned into orbiting debris might even help us figure out what kind of damage an asteroid could do to Earth. So yeah, these little guys may be fast, hard to find, and kind of flaky, but they've got loads of secrets to spill. By the way, Earth might have had 2 real moons once, and those were not mini-moons. One of them was our familiar one, and the other one was a smaller buddy moon tagging along. Sadly, things didn't end well for the little guy. Scientists have been wondering for years why one side of the moon, the one we always see, is smooth and flat, while the far side, the one that never shows its face, is all bumpy, crusty, and way thicker. Looks like the moon has a good side for selfies and a rough don't-take-my-picture side. So, according to a new computer model, that lopsidedness might be the result of a slow-motion cosmic fender bender. The theory goes like this. Millions of years ago, our moon had a smaller moon sibling cruising along with it in space. Everything was chill like for 80 million years. Both moons had the same vibes, similar makeup, same color, just one was 3 times bigger than the other. Then, gravity happened. As the moons drifted further from the Earth, the Sun's gravitational pull stepped in, messed with the smaller moon's path, and eventually sent it crashing into the far side of the bigger moon. This wasn't a huge action movie explosion. The speed was more like a slow but firm crash, not fast enough to melt rock, but just strong enough to squish one moon into the other like cosmic Play-Doh. The smaller one didn't leave a big crater. It basically smeared itself across the far side, leaving behind that mountain-heavy terrain we see today. After the crash, space got really messy. Trillions of tons of moon debris got thrown into orbit, and for a few days, the whole system was just dust, rocks, and chaos. And Earth? It got pelted with moon chunks for up to 1 million years afterwards. Some of those space rocks were the size of cities. So, in the end, our natural satellite may be a mix of 2 moons mashed together, one face smooth, one face forever marked by its lost twin. It's kind of tragic, kind of epic, and explains why the moon looks like it lost a fight on one side. So, you kind of forgot to duck, huh?
The moon might be hiding trillions of dollars worth of materials beneath that dusty surface, and NASA is about to get a piece of it soon. Their new lunar drilling tech just passed its first big test, and it could open up an entirely new frontier: space mining. This isn't just a scientific milestone. This could change the US economy forever, and maybe even reshape life on Earth. That's because they found something rare in lunar soil. Something that could become essential for us in the future: helium-3. Okay, so you know helium, right? It's the gas that makes birthday balloons float. Helium-3 is not that. It's a special isotope of helium, which basically means it has the same number of protons, 2 by the way, but a different number of neutrons. That's chemistry speak for it's rare, like super rare. Here comes the sad part. Earth had helium-3 once, a lot of it actually. But during our planet's formation, a lot of it escaped into space. Turns out, it's super light, so it didn't stick around. But we can still find it here and there, mostly inside our planet. I mean, there's some of it literally trapped underground. Or even a lot, as some recent studies might suggest. But still, the problem is that extracting helium-3 is expensive, limited, and seriously difficult. So difficult, in fact, that getting it from the moon suddenly sounds like a piece of cake. To really understand why extracting helium-3 in space might be easier, we need to quickly compare Earth and the moon. So here's the sun, right? This huge ball of fire in the sky constantly shoots out tons of helium-3. When this helium-3 reaches Earth, our planet's magnetic field acts like a giant invisible shield, basically saying, "Nope, not here," and it deflects most of it away. But the moon doesn't have a friendly protective magnetic field like Earth does. So when helium-3 reaches the moon, it hits the surface directly and gets trapped in the lunar regolith. I'm talking about that loose layer of dust, soil, and rocky debris covering the moon. And there might be tons of it, literally. Some estimates put it somewhere between 1 and 3 million tons of helium-3. The best part is that almost all of it is probably sitting right in the top layer of lunar soil. So instead of heavy-duty drilling, it could be as easy as just scooping up some moon dust. That's why a lot of people think getting helium-3 from our natural satellite could actually be way easier, or maybe even cheaper, than digging deep underground here on Earth. Now, you're probably thinking, why go through all that trouble? I mean, if it doesn't work for birthday balloons, what's the big deal with helium-3? Well, for starters, it's already being used in advanced medical tech, like magnetic resonance imaging and X-ray. But here's the real game changer. Helium-3 could actually end our dependence on fossil fuels for good. This rare isotope could be used for advanced nuclear fusion reactors here on Earth. In other words, it could give us nuclear energy that's not just super efficient, but a whole lot safer too. See, most nuclear power plants today run on a process called fission. They use uranium-235, and when those atoms split, you get a ton of energy. But you also get something else: radioactive waste. And yeah, it's just as dangerous as it sounds. But helium-3 is different. It could power future reactors with a process called fusion. If you mix helium-3 with a type of hydrogen called deuterium, you get a lot of energy, but without the dangerous waste. It could be cost-efficient too. Let's say a single space shuttle cargo bay could carry about 25 tons of helium-3. That would be enough to power the entire United States for a year. And scientists believe there's enough helium-3 on the moon to power the whole world for 10,000 years. These are only estimates for now, but the future potential is so exciting that the demand for helium-3 is already skyrocketing, and so is its value. In 2024, some experts say that the helium-3 market was worth about $670 million. This year, it's expected to hit around $730 million. And 10 years from now, experts believe it could reach nearly $1.6 billion. Sorry for all the numbers, I just wanted to show you why mining the moon matters. It might actually save us from a future energy crisis by giving us almost endless, clean nuclear power. Everything sounds great so far, but there's one big challenge. Mining helium-3 on the moon is one thing. Bringing it back to Earth is a whole different story. So let's look at one possible solution. First, robots or specialized machines would drill into the lunar soil or simply scoop up moon dust to collect the helium-3. Then it gets packed into containers and launched off the moon, heading for Earth. When the containers get close to Earth, a ship called the Space Rapid Transit will pick them up in orbit. Think of it as a reusable space truck with engines that can even use air for thrust. Finally, the ship would land at an airport here on Earth. From there, the helium-3 would head straight to power plants, giving us clean, safe, and almost unlimited energy. See how challenging it sounds, right? Of course, specialists are still figuring out the best way to transport helium-3. But one thing is certain, we're getting closer and closer to building a full mining base on the moon. NASA recently tested a new drill technology called Trident. And as soon as it touched the lunar surface, it started working right away and performed perfectly. For now, its main purpose is to bring soil to the surface so scientists can study it. They want to learn more about how strong the lunar regolith is and how it reacts when drilled. That's definitely an exciting step towards extraterrestrial mining. Because it's not just helium-3, you know. There are a lot of other valuable things that can be taken from the moon. For example, there's water ice on the moon, and from that, we could extract oxygen and hydrogen. Then there could be rare and expensive metals like platinum, rhodium, and iridium. We could even mine iron, silicon, and aluminum, which would be perfect for building things directly in orbit, like future space stations or other infrastructure. Now that we know how important mining the moon could be, you're probably wondering, is any of this even allowed? I mean, who actually owns the moon? The short answer? Nobody. Even though NASA is up there doing research, that doesn't mean the United States owns the moon. Back in 1967, some nations signed the Outer Space Treaty. It basically says no one can claim ownership over our natural satellite or any other celestial body. Not an asteroid, not a planet, not even a random rock floating out there. So, if a country wants to explore the moon, sure, they can do it, but they can't plant a flag and say, "This is ours now." Here's where it gets messy. Companies. There isn't much of an agreement about what private businesses can and can't do out there. For example, a private company sets up a moon base. They land a successful spacecraft, build a small station, and even start digging. The base itself belongs to them, sure, but the land they're sitting on does not. Everyone is on the same page up to that point. The tricky part is, the treaty doesn't really spell out what happens to the materials they dig up. Nobody is totally sure if those resources would even belong to them. And if the materials are not technically the company's, can they even sell them? It's hard to say. So yeah, sorry. Even if you had the cash to build your own lunar base, you probably can't just scoop up helium-3 and bring it back as a souvenir. I mean, unless you want to risk becoming the first person ever banned from the moon. Hey, does anyone remember the gold rush? Back in the 19th century, prospectors were flooding California rivers with a pan in hand, chasing wealth. Well, scientists now say it might be time for the moon rush. Because apparently, precious metals worth over $1 trillion could be hiding underneath the surface of the moon. That's a lot of money. However, can we really reach it? And if so, who does it belong to? If you have ever paid close attention to the pictures of the moon, you probably noticed a lot of holes and craters. Our satellite is like a giant Swiss cheese. It has over 1.3 million craters, if you count those larger than 0.6 miles. But today, we're focusing on about 6,500 really big ones, those over 12 miles wide. Those were not made by little green men or little green moles, but rather by asteroids crashing into the moon since eternity. Scientists compared moon scans to meteorites, and after crunching the numbers, they think there could be a fortune in platinum hiding in those craters. What's exciting is that many of these resources could be just a few feet beneath the surface. The moon doesn't have an atmosphere like Earth, so there's no wind, rain, or earthquakes messing things up. That means those asteroid crashes left their priceless metals pretty much right where they landed, undisturbed in lunar dust for millions of years. With each crater like a giant space bowl, catching platinum, iridium, palladium, and other metals. On Earth, we have to drill super deep just to get a tiny bit of these. By the way, did you know that most of the mineable gold on Earth likely came from ancient meteorites? When Earth first formed, almost all the original gold sank into the core. The stuff we can actually dig up today is probably what's left when space rocks slammed into the crust billions of years ago. So maybe you wonder why not reach for the asteroids and mine there? Well, that's because they're out of reach. Yes, in theory, it would be possible to mine from asteroids, but obviously the moon is way closer and easier to get to than any other giant rocks floating in space. We've already walked on it and brought back pieces of it to Earth, so it's fair to say we are familiar with it. This makes mining it a much smarter step than chasing unpredictable asteroids. However, asteroids are next on the list. Also, when it comes to mining the moon, it's not just about the prize. Some of those craters have frozen water. We know that because several missions, like NASA's Lunar Reconnaissance Orbiter and India's Chandrayaan-1, have found frozen water ice in dark craters near the moon's poles. This ice is super valuable because it can be broken down into oxygen and hydrogen. They are the parts needed to make rocket fuel. It could also be purified for astronauts to drink, or even used to help grow plants. Imagine filling up spaceships with fuel right on the moon before flying off to other planets. Not only does that sound pretty cool, but it's also economical and convenient. That would save us a ton of money and effort. And if we're already stopping to refuel, why not stick around and set up shop? It's about building a whole new space base and turning the moon into a launching pad for exploring deeper space. A moon base would let scientists study wild space weather, practice building habitats, and test robots in real lunar dust. I can't be the only one excited for the future where robots stream their live missions from the moon. The skills and knowledge we develop there could be essential for living on Mars or exploring the moons of Jupiter and beyond. This is not as far-fetched as you might believe. Companies like Astroforge and Karman Plus are working on tech to mine asteroids, and maybe the moon someday. NASA's Artemis program is trying hard to set up a sustainable human presence on the moon in the next decade. And Europe's space agency is also eyeing lunar resources. So yeah, the idea of people and robots working together on the moon is probably just a matter of time. Still, it's not as simple as it sounds. There are big questions that humanity faces. Just like with the original gold rush, it's a bit of the Wild West when it comes to rules. The Outer Space Treaty, signed in 1967, says no country can claim the moon as its territory. However, it's pretty vague when it comes to private companies mining resources. So, if you build your rocket and mine some platinum first, is it yours? Well, as for right now, it's a guessing game. Countries are debating and trying to figure it out before the space gold rush turns into a lunar free-for-all battle royale. Then, there's the challenge of protecting the moon's one-of-a-kind environment. Some craters are so quiet that scientists dream of turning them into giant space observatories that study the universe without any radio noise from Earth. Mining nearby could shake things up or kick dust into the air. Lunar soil could dance. That would definitely annoy researchers. Plus, some parts of the moon have been untouched, and mining could wipe out cool spots we haven't even fully explored yet. So basically, we want to make sure we don't turn the moon into a lunar construction site before we've learned all its secrets. That's why some experts suggest setting up protected zones on the moon, like national parks here on Earth, where mining and heavy machines just aren't allowed. That way, we get the benefits of lunar resources but keep the moon's most important areas safe for research and discovery. But here's an even bigger question. How is this thing going to affect us casual Earthlings who can't take a walk up to the moon with our metal detectors and explore? The moon's rare metals aren't just worth a lot. They could actually be super useful for future tech. Platinum group metals, which might be found in lunar soil, are used in things like medical gear, satellites, and even some types of batteries and fuel cells. If the moon really is sitting on $1 trillion treasure, it could boost tech industries and possibly lower costs. There's also helium-3, a rare isotope found on the lunar surface. Scientists think it could someday be used for nuclear fusion, providing a clean, powerful source of energy that doesn't create greenhouse gases or long-term radioactive waste. If fusion becomes possible, even small amounts of helium-3 could power entire cities. One cool perk of using resources from space is that we could cut down on all the digging and pollution here on Earth. That means less damage to our environment and more sustainable ways to keep up with our growing population's needs. On the other hand, all these new opportunities could create new challenges. Of course, there's going to be a cosmic tug-of-war with who gets the goodies. Nobody wants the fear of missing out on a moon rush. Bottom line, lunar mining isn't just a science experiment. It's something that could affect economies, technology, and the environment here on Earth, for better or worse. When I was a kid, hundreds of years ago, we had the moon bases on the covers of our science books. One of the reasons why moon landing projects became so rare is that it just wasn't financially viable. Why should a country spend resources to get to the moon if there's nothing valuable up there? However, now that we think there's something out there, everything could change. That's why I already imagine myself working 9 to 5 on the moon, fixing robots and growing moon plants. But it's time to get back to Earth, so to speak. Nobody's setting up a moon McDonald's or booking lunar Airbnbs just yet. Even the most optimistic experts say we're still decades away from big mining operations or permanent lunar bases. For now, most missions will be robotic, experimental, and with price tags that will make your head hurt. So until we all get our moon mining helmets, it's something to think about while moon gazing. What about that wealth hiding on the bright side of the moon? Thank you for watching. That tiny dot in the sky is an asteroid called 2024 YR4, and it gave scientists a serious scare. Early projections showed a 2.3% chance that it could hit Earth. That might sound small, but for an object big enough to wipe out a city, it was enough to raise alarms. Now, there's good news and bad news. The good, it's no longer on a collision course with our planet. The bad, it might be heading for the moon instead. Astronomers first spotted it in the El Sos Observatory in Chile, back in December 2024. Judging by how bright it appeared, they estimated its size to be somewhere between 130 and 300 feet wide. That's about the size of a football field. If something this big hit Earth, it could be truly catastrophic. I mean, not on the level of the asteroid that wiped out the dinosaurs, but still enough to destroy an entire city, depending on where it lands. Drop it over Paris, London, or New York, and you're looking at complete devastation across the city and nearby areas. That's why it was considered one of the most dangerous space rocks to ever come near us. It makes total sense that this asteroid became a bit of a celebrity. From the moment it was discovered up until February 2025, the risk of a collision just kept climbing. But now we can breathe a little easier. New calculations from NASA have completely ruled out any chance of impact. In fact, there's no serious threat from this asteroid for at least the next 100 years. Okay, but how did we go from this is a threat to, oops, we were wrong? That happens quite often, actually. I mean, an asteroid seems risky at first, then it gets even riskier, and then, out of nowhere, it's suddenly safe. Does that mean we can't trust their math? You see, the first time specialists spot an asteroid, it's really just a tiny dot of light in the sky. At that point, they have no idea what it is or where it's headed. Then they have to observe it again and do some math. That will help them figure out the path they're moving on. But even then, it's still a bit uncertain. They don't really know where the asteroid is going, so the risk corridor is this huge area where it could fly through. If any part of that corridor crosses Earth, the asteroid is considered a threat. Usually, at least 3 observations are needed to figure out its orbit. Basically, how fast it's moving and where it's headed. A lot of times, as they start to get a clearer picture, the risk zone still overlaps with Earth, so it looks more dangerous at first. But typically, as they keep tracking it, the risk zone gets smaller and moves away from Earth, and suddenly, the risk drops. And they keep narrowing down the uncertainties until they can confidently say, "Relax, y'all, it's not heading for Earth." And that's exactly what happened to just our famous 2024 YR4. So we can all relax a bit now, right? Yeah, we know that 2024 YR4 won't hit us, but it could end up crashing into the moon instead. At first, projections said there was a 1.7% chance of that happening in 2032, but recently, that number has gone up a little to 3.8%. If it does hit the moon, though, it won't be dangerous for us. I mean, there won't be any shockwaves felt here on Earth, and the moon isn't gonna crack in half. Experts say nothing really shocking or concerning would happen, but it would be an awesome opportunity to see a lunar impact. If we're lucky, we might even catch the exact moment it happens. And if we miss it, we will still get to observe a brand new crater on our natural satellite. Such events are pretty common for the moon, since it doesn't have an atmosphere to protect it from incoming debris. In fact, there are hundreds of detectable impacts each year. See those bright spots lighting up? These are real images of asteroids hitting the moon. But specialists aren't just sitting around and waiting. They've been keeping an eye on lunar impacts for years. For example, the European Space Agency has a project called Neliota, where they use a powerful telescope in Greece to track these impacts. They've recorded over 100 tiny explosions from space rocks hitting the moon. They also have the Lumio mission, which is a small satellite that counts lunar impact flashes on the far side of the moon, the side we can't see from Earth. These observations help scientists understand how often the moon gets hit and how this might affect astronauts and lunar bases. Now, 2024 YR4 might be a special case. That's because most space objects that collide with the moon are really small. We've never seen a collision with something larger than about 160 feet. If YR4 does hit, it could be an amazing sight. So yeah, scientists are kinda hoping it happens. But 2024 YR4 isn't the only asteroid on the radar. There are actually quite a few others that have been classified as potentially hazardous. In simple terms, that means this one might cause us some trouble. You see, there are millions of big space rocks out there in the solar system, mostly chilling in the asteroid belt between Mars and Jupiter. But only a few ever get close to Earth, and even fewer actually pose any real risk. NASA calls asteroids that orbit within 30 million miles of Earth near-Earth objects, and within that group, there's a smaller bunch of really big ones that orbit super close to us. If one of those were to hit us, it could be a big deal. There are about 2,500 of those asteroids at least that we know of. But here's the good news. Specialists don't expect any of them to hit Earth anytime soon. A few might come pretty close though, or already have, like the 2014 TN17, an asteroid that's about 540 feet wide. It got pretty close to us in March 2025, zipping by just 3.2 million miles from Earth. That's roughly 13 times further than the Moon. So yeah, not exactly close, right? But when you think about the vastness of the universe, it's actually kind of near. In fact, that was the closest this asteroid has come to Earth in nearly 300 years. Thankfully, nothing happened, and that asteroid has already drifted away from Earth again. But it's not like you need to lose sleep over asteroids that could hit our planet. Little asteroids enter Earth's atmosphere every single day. It's the big ones we worry about, like the ones you see in Hollywood movies, like Armageddon. But asteroids like that are being constantly monitored. All the objects we know of today have 0 or 1 chance of impacting Earth. And if things change, there are a few strategies that could be used to save humanity from an impact. Take the DART mission, for example, which happened in 2022. This was NASA's first test of planetary defense. They successfully managed to deflect an asteroid off its course using a spacecraft. In this case, the asteroid didn't pose any threat to Earth, but it was the perfect test subject. There are also more experimental ideas out there. For example, lasers could vaporize part of an asteroid to create a thrust effect, pushing it off course. Another idea is the gravity tractor, a big spacecraft that slowly tugs the asteroid away using its own gravitational pull. But all of these are still just ideas for now. If we can't pull any of those off, authorities would probably still have enough time to evacuate the impact zones. So yeah, I wouldn't stress too much about an asteroid impact.
In 2025, humans will have a unique opportunity: travel to the Moon. So far, only 12 people have walked on Earth's natural satellite, but a private company is offering tourists a chance to change that. If you are hog-stinky rich, you can pay $750 million to spend several days exploring the Moon and watching Earth from a distance. You can even join unique scientific experiments. Now, humans also want to build their forever homes on the Moon. In fact, NASA believes that North Americans may have their own share of the Moon by 2040. And you don't even need to be an astronaut to buy a plot of land on the Moon. Of course, billionaires are already making plans. Their first idea is to exploit natural resources. The Moon is packed with stuff that is rare here on Earth, like helium-3 and many rare Earth minerals, or more precisely, rare Moon minerals. But I digress. Hey, if you can get your hands on some of it, you may get even richer. First, helium-3. It's great for clean nuclear energy, but it's super rare on Earth because it escapes into space. The Moon, though, has tons of it, enough to power Earth for 1,000 years. Rare Earth minerals are not actually rare on Earth, but they're hard to mine because they react with oxygen. On the Moon, hey, there's no oxygen, so we could easily get loads of these materials to make better tech, like electronics and batteries. Scientists aren't thrilled about this. For the first time, they have a chance to explore 4.5 billion years of space history. Because the Moon's soil has stayed the same for billions of years. Studying its rocks could reveal lots of secrets about the universe's origins. But if billionaires mine the Moon and destroy these rocks, all that knowledge could be lost forever. Another problem with exploring the Moon is the size of it. The Moon is big, but the best spots, the ones with water and sunlight, are limited. Most of the lunar surface is dangerous because of earthquakes or moonquakes, radiation, and meteorites. That means tourists, scientists, and mining companies would be elbowing each other in 3 small regions. The first region is called the Peaks of Eternal Light because there's always sunlight over there, making it a great energy source for telescopes or human colonies. The second spot is the far side of the Moon. Here, radio signals from Earth are not so strong. It's not just peaceful and quiet there. It's also a great place to set up a telescope and study the universe. The third place is called the Pits of Eternal Darkness. It's where all the trolls on social media go on vacation. Nah, it's really because no sunlight reaches that area. This place is even better for scientists because they can use special astronomy tools to study the most distant parts of the universe. This is also where you can find about 1 billion tons of water. If scientists could visit the Moon and study it, they would make amazing discoveries. But today, there are no international laws protecting space. No country can own the Moon, but this can't stop a private mining company from calling dibs on a particularly good spot. In the past, a bunch of nations signed the Outer Space Treaty, and they agreed that space exploration was supposed to benefit all humankind. But exploring it is not cheap in the first place. Taking a single gallon of water from the Moon to the Earth is extraordinarily expensive, and I bet not everyone can afford that. Human activity on the Moon is also extremely dangerous because it might change its atmosphere. Now, to understand it better, let's look at the surface of the Moon. This floating rock has many craters that have been forming for billions of years. When a meteorite crashes into the Moon, fine dust called regolith, with particles so tiny they can cut like glass, rises into the air. This process once created the atmosphere of the Moon, and this atmosphere is quite different from the atmosphere of Earth. A big rocket landing on the Moon can launch this fine dust into the lunar sky, and the difference here is that the space objects crashing into the lunar surface are actually gentler. A rocket landing is so intense it can increase the number of atoms in the sky 100,000 times. If the number of atoms in the atmosphere grows, the air turns into a dusty plasma. This means that you'll be breathing in air as toxic as the one that poisoned miners in the olden days. Such an atmosphere could end space tourism too, because it makes electronics malfunction and machinery shut down. Well, truth be told, our own presence on the Moon is already dangerous. When scientists discovered water on the surface of the Moon, they were super excited to study it. This was their chance to understand where this water came from, and even figure out how water appeared on Earth. But when our spacecraft land on the Moon, outgassing occurs. This means that the water on the surface evaporates. This evaporated water can contaminate the water on the Moon, ruining all scientific data. Because when astronauts take a sample of the lunar water to study it, they will get the water from Earth they have brought along. Bummer, really. And it's not just the water we contaminate, it's everything. A spaceship can carry any living thing from Earth to the Moon. It can also bring extraterrestrial life forms back to Earth. This type of contamination is extremely dangerous because it can put human lives at risk. Something similar happened when Europeans were exploring unfamiliar lands they came upon in the Americas. They accidentally introduced new microbes to the natives they met. And since the immune systems of the native population were not used to those new bacteria and viruses, they got sick and worse. At the same time, Europeans also became ill with diseases their bodies didn't know about yet. And even though moon tourism is not happening yet, humans are already littering the lunar highlands like their own backyard. In 2024, an artist named Jeff Koons sent a sculpture to the Moon. The sculpture is a transparent box filled with spheres, and it got to the Moon thanks to a ride on a SpaceX Falcon 9 rocket. In each sphere, all the way to the Moon to see this sculpture. You can purchase an NFT of each sphere. Or not. Back in 1971, the crew members of Apollo 15 also left a couple of things on the Moon. A figure created by a Belgian artist and a commemorative plaque to honor other astronauts who couldn't be there. And it's not just art that humans dumped on the Moon. If you take a walk, you might just stumble upon 413,000 pounds of materials left behind, including a gold olive branch, a falcon feather, a silver astronaut pin, a Bible, some golf balls, a hammer, and even leftover urine collection kits. Most of this stuff was left behind by the astronauts that explored space between the 60s and 70s. So you can find moon rangers, lunar probes, and orbiters that are decades old already. Now, to be fair, bringing back unnecessary equipment costs a ton of money. And back in the 60s, their priority was the safety of the astronauts. The sad truth is that the moon is already turning into an extraterrestrial landfill, and we don't even live there yet. But now we want to settle there, so NASA is trying to get rid of all this trash. The good news? Hey, you can be part of this process. The space agency launched a competition called the Lunar Recycle Challenge, and if you want to join it, you must find ways to reduce the amount of litter produced and recycle it into materials that can be used for space exploration. To win, you need to develop a way to completely recycle the trash that is on the surface of the moon. You will help science and win $3 million. And if you get this sum, well, you might finally afford a ticket into space.
Under your feet, the moon is pulsing. You feel danger with every pore of your body. The lifeless satellite, or so you thought, stays still for a second before knocking you down to the ground with a powerful tremor. Is it a moonquake? For years, scientists believed the moon was completely inactive, but the newest evidence seems to suggest that this idea is totally wrong. Researchers from the University of Maryland have recently discovered 266 mysterious ridges on the far side of the moon. And these ridges likely point to recent geological activity. So, are we really talking moonquakes? Well, kind of. The ridges are located in volcanic regions that formed 3.2 to 3.6 billion years ago. But they appear much younger than expected. Typically found in clusters of 10 to 40. They're often located in areas where the moon's surface is structurally weaker. Now, when astronomers speak about recent, don't take their words literally. They don't mean last year or even decade. Most models scientists created suggested that the moon's geological activity ended 2.5 to 3 billion years ago. But the new information hints at the possibility that these formations have been active within the last billion years. Some of the smaller ridges seem to have formed as recently as 200 million years ago, and that is considered relatively young on the moon's timescale. It means that the moon may still be experiencing geological changes today. These discoveries kinda challenge our understanding of the moon's history and evolution. But how did scientists come to these conclusions anyway? Researchers from the University of Maryland and the Smithsonian Institution used crater counting to estimate the age of lunar ridges. It works like this. Surfaces with fewer craters are younger, and the more craters some region has, the older it is. Plus, the analysis showed that some ridges cut through already existing craters, meaning they likely formed around 160 million years ago. In geological terms, this is very recent, suggesting that these ridge-forming processes may still be happening. Another cool thing is that the ridges on both the near and far sides of the moon are similar, which means they may have formed through the same geological processes, having been shaped by the same forces. These forces might include the moon's gradual shrinking, thermal contraction, and shifts in its orbit. We'll talk about it a bit later. Another argument supporting the idea of a still active moon is decades-old data from the Apollo missions. They had already detected shallow moonquakes with the Apollo Lunar Seismic Experiment, recording 28 quakes ranging from magnitude 1.5 to 5. Researchers believe that these ridges may be linked to similar seismic activity. Now, about that bizarre shrinking of our natural satellite. Scientists believe the moon formed about 4.5 billion years ago when a Mars-sized object collided with early Earth. This catastrophic impact likely sent bunches of superheated material into space. Eventually, they came together and formed the moon. In its early years, the moon was just a molten world, shaking from intense volcanic and seismic activity. So, the moon used to be a molten mess floating through space. But when did it actually solidify? Scientists have finally figured it out 4.43 billion years ago. This was a huge turning point, not just for the Moon, but for Earth too. After all, the giant impact that formed the Moon might have also been the final blow that made Earth stable enough to support life. In any case, billions of years passed. The Moon gradually cooled and contracted. And now look at this modern-day rocky sphere illuminating our nights. But the Moon isn't completely rigid yet. It still keeps cooling. And this slow cooling of its core might be one possible reason for the Moon's continued activity. As it cools, the Moon's interior contracts, which leads to cracks and shifts in the crust. One of the clearest signs of this contraction is found in the lunar maria. See these large dark patches on the Moon? Those are called maria, areas formed when lava filled ancient asteroid impact craters and then solidified. Then, over time, the cooling and contracting crust created these wrinkle ridges. Another factor of the ongoing geological activity could be the Moon's gravitational interactions with Earth. Such non-stop powerful interactions likely create surface stress and trigger tectonic movements. It's all good and exciting, but can this activity on the Moon actually affect humans? In a sense, it can. The Moon has long been seen as a stable place for future bases and resource extraction. But the discovery of this ongoing geological activity is pretty worrying. If the surface is still shifting, future settlements, infrastructure, and mining operations could face serious risks. That's why, at the moment, we need seismometers and ground-penetrating radars to better understand these movements. It will allow us to assess potential dangers before any long-term missions begin. By the way, there's another potential problem future lunar missions might have to deal with, and it's moon dust, aka regolith. Apollo astronauts quickly learned that this jagged, sticky dust gets everywhere and can damage suits, equipment, and even health. A new study from Texas A&M engineers found another problem. When rockets land or take off, they kick up regolith, which can become a collision hazard, especially with many spacecraft bringing crews and cargo to the Moon. Lunar regolith comes in all sizes, from tiny dust particles to large rocks. The main ingredient in moon dust is fine silicate materials, about 70 microns in size, like a human hair. They formed over billions of years as meteors and asteroids smashed into the Moon's surface, grinding much of it into powder. Unlike Earth, the Moon has almost no atmosphere. It's incredibly thin, so there's no wind or water to smooth out the dust. On top of that, constant exposure to solar wind has given the regolith an electrostatic charge, making it stick to anything it touches. Apollo astronauts quickly found this out the hard way. Moon dust clung to their suits, got trapped inside their landers, and stuck to everything. Worse, it became a health hazard, causing eye irritation and breathing problems inside their spacecraft. But at the moment, it seems like a problem for future us. A much more important issue is finding water to support future missions, and China is going to deal with it. It's getting ready for a big mission to look for hidden ice on the Moon. As part of the Chang'e 7 mission in 2026, a flying robot will explore deep craters at the Moon's south pole, where ice might be trapped. If they manage to confirm it, this could be a game changer for future lunar missions. Astronauts will have a water source and even fuel for space travel. The mission is a key step in China's plan to land astronauts on the Moon within 5 years. While signs of water have been found before, like in soil samples from Chang'e 5's probe and observations by NASA and Indian spacecraft, scientists believe that deep ice deposits are the real key to supporting future missions. The south pole of the Moon has some incredibly deep craters, and experts think ice could be hiding inside them. The flying robot will try to explore one or more of these craters after landing. If it does find the ice, it could make long-term Moon missions much cheaper and more practical, helping astronauts live and work on the Moon. Some scientists also think that this discovery could offer us some clues about extraterrestrial life. In any case, Whether we find water on the moon and learn to deal with that pesky dust or not, the recent discovery of those young lunar ridges is a game changer. If the moon is still geologically active, it means we don't know as much about our closest neighbor as we thought. What else could the moon be hiding? Are we really prepared for the idea that this lifeless satellite might actually be more dynamic than we imagined? Future missions, which might not be as safe as we once believed, will probably show. About a century ago, people envisioned the 21st century as a time filled with quirky inventions. They weren't far off the mark. We're now one step closer to establishing an actual settlement on the moon. Before we can create a new home up, we need to find a way to stay connected, beyond just transportation and shipping. Being able to send a simple text, even something as casual as, "Hey, how are you?" is essential. We can't move to the moon if we're cut off from Earth. Let me spill some tea. A lunar 4G network is currently being developed. The company leading this initiative is none other than Nokia's Bell Labs. The company, bought by the world-famous Finnish company that started out as a paper mill in the 19th century and later ventured into the cell phone industry, creating iconic devices long before Apple launched its first phone. Once the network is completed, it will be loaded onto a lander, deployed, and connected using specialized radio equipment. But don't think this is just a fun experiment. It has significant purposes. The Lunar Outpost rover, one of the vehicles involved in this mission, will thoroughly explore an area known as the Shackleton Connecting Ridge. Another rover, the Micronova, will investigate a lunar crater in search of ice. When they discover ice and capture images, this information will be first transmitted to the lander and then relayed to Earth, an unprecedented achievement in history. Moreover, the importance of a reliable phone connection cannot be overstated. Currently, astronauts communicate via radio. But NASA aims to establish a lunar communication system capable of supporting high-resolution video. Effective communication during space missions is as crucial as food and water, and with this new lunar 4G technology, video calls on the moon could soon become a reality. Plus, thanks to lunar 4G, we'll be able to track how the endangered species sent to the moon are doing. Oh, sorry, I completely forgot to mention something important. As more species edge closer to extinction today, scientists are collecting samples from animals, plants, and other organisms to store in biorepositories around the globe. Unfortunately, the conditions on Earth are far from ideal for these modern-day Noah's Arks. Hence, the decision to build 1 or 2 vaults on the moon makes perfect sense. On the moon, there's a permanently shadowed region at its south pole. It may seem like a fortunate coincidence, but some lunar craters may meet the criterion of temperature, -320 degrees Fahrenheit, which is precisely what we need for long-term self-storage. Initially, the plan was to construct the vault in lava tubes that run beneath the moon's surface, but that would have posed significant risks. This design requires a special solar-powered cooling system, and any accidental loss of power could be catastrophic, resulting in the destruction of all the samples. However, if we built it in a forever frozen shadowed area, the vault wouldn't need any energy or human maintenance. Bingo! It sounds almost too good to be true, and indeed there are several complications. For instance, dust is an omnipresent issue on the moon, infiltrating everything. If the storage requires seals, a dust mitigation system must be developed, which has not yet been created. So for now, it remains a theoretical concept rather than a practical solution.
40, 50 feet, why don't you turn around and let them get a view from there and...
I know you want to learn about real things, not just concepts. Here's something real for you. The moon is full of human waste, carefully packed into bags. According to estimates, there are around 96 of these bags you'd probably prefer to never open. But you never know what exactly is hidden inside. It could be any product of the human body out there. So, if we ever make it to the moon and you accidentally stumble upon a mysterious bag, my advice is to resist the urge to open it. Instead, you can hand it over to scientists. They say they're eager to get their hands on them. Humans are incredible, in a rather unfortunate way. We haven't even established a proper settlement on the moon yet, but there's already around 200 tons of junk scattered about. It piles up there as if it were a teenager's room rather than a celestial body. Alongside those rather unappealing human waste bags, you'll also find cameras, drills, towels, brushes, rakes, a multitude of other technical items, and, surprisingly, a falcon's feather. I'll explain that in a moment. At the end of Apollo 15's final moonwalk, David Scott pulled out a falcon's feather and a hammer to demonstrate Galileo's theory that in the absence of air resistance, different objects fall at the same rate. Amidst all that junk, there's an actual piece of art, so we could say that the moon, if it doesn't have the very first art museum, at least boasts a small exhibition. The crew of Apollo 15 took a 3.5-inch tall aluminum figure to the moon. Created by a Belgian artist, it's called the Fallen Astronaut, and it was laid on its side with a plaque listing the names of astronauts and cosmonauts who contributed to exploration. But the list of odd objects on the moon doesn't end there. If you ever find yourself in need of cash, you can find it on the moon, since a stack of $2 bills was simply forgotten there. Yep, a lot of material has been collected since 1969, when humans first stepped on the moon.
It's one small step for man, one giant leap for mankind.
Our natural satellite was first seen in a telescope in 1609. But what about its true age? To understand that, we need to start with how the moon first formed. Back in the mid-80s, a conference in Hawaii brought together a bunch of scientists to figure out where the moon came from. They came up with a pretty cool idea. The moon probably formed with the stuff that our planet Earth donated. Picture this. A Mars-sized object crashed into the early Earth, flinging molten materials into space, which eventually came together to become the moon we see today. This theory clears up a lot of mysteries. For instance, it used to baffle folks why the moon has such a small iron core. The answer is simple. It formed from Earth's outer layer, which isn't rich in iron. And that pale crust of the moon? It's just minerals that floated to the top when the molten moon cooled down. At first, the moon was super close to Earth, but it's been slowly drifting away at about 2 inches a year, even while you're watching this video. Figuring out when this all went down, though, is a bit tricky. The Apollo astronauts brought back a bunch of moon rocks, which helped scientists estimate their ages. The oldest ones are around 4.35 billion years old, which is about 200 million years after the solar system kicked off. So, here's the thing. There's no exact date for when the moon formed, but there are several interesting theories. One idea is that the age of these rocks could mean the moon is around 4.35 billion years old. But some scientists who look at how planets form think that most of the material in the early solar system came together way before that 200 million year mark. They argue that a big impact that created the moon happening that late seems pretty unlikely, which means the moon could actually be older than 3.5 billion years. Another interesting thought is that the moon might have gone through some serious heating events as it moved away from Earth. This is similar to what happens on Io, one of Jupiter's supervolcanic moons. The gravitational pull from a bigger body can stretch and compress a smaller one, generating heat, like when you squeeze a rubber ball. The rocks on both Io and the moon warm up this way. Rocks have radioactive elements that act like internal clocks, helping scientists figure out their ages. The catch is, if the moon heats up too much, it resets those clocks and only starts keeping time again once it cools down. So those rocks that are about 4.35 billion years old might not actually mark the moon's birthday. They could just indicate a time of tidal heating. This suggests, once again, that the moon had to have formed even earlier than that. The moon's volcanoes are not dormant. and they can erupt any minute. For years, we lived knowing nothing about it, but now it's officially proven thanks to China's Chang'e 5 mission's shocking discovery. The lunar soil samples it brought back to Earth contained something absolutely unexpected, hinting that volcanic eruptions may have occurred on the moon as recently as 123 million years ago. Geologically, that's practically yesterday. But the big question is, are we safe down here on Earth? We've long known that the moon was once volcanically active due to the dark regions, lunar maria, on its surface. These maria, the dark plains that give the moon its characteristic markings, are ancient lava flows that date back to around 3 to 3.8 billion years ago. Until recently, scientists thought that those ancient flows marked the end of the moon's volcanic activity. But the Chang'e 5 mission brought back lunar soil that included several microscopic glass beads, and 3 of them in particular revealed an extraordinary story. They formed around 123 million years ago from volcanic eruptions. An uncertainty range is a mere 15 million years. The discovery of those tiny beads is super important because of their composition and rarity. Measuring between 20 to 400 microns, which is smaller than a grain of sand, these beads are volcanic in origin. And this fact sets them apart from most other lunar glass beads, which typically form due to meteor impacts. Impact events on the moon create glass by melting surface rock with incredible heat and pressure. The result is tiny glass beads scattered all over the landscape. Yet, the volcanic beads identified in Chang'e 5's sample were formed by magma erupting from beneath the moon's crust and cooling it into glass as it reached the surface. By using uranium-lead dating, which measures the decay of uranium into lead within the beads, scientists managed to pinpoint their age with striking accuracy. The results suggest that the last known volcanic activity on the moon happened within the past 200 million years, making it a recent event in the moon's long history. This discovery also aligns with prior observations of unusual surface features known as irregular mare patches. Those are smooth mounds surrounded by rocky terrain. They were first spotted by NASA's Lunar Reconnaissance Orbiter in 2014. These patches appear much younger than other lunar features, potentially formed by volcanic eruptions less than 100 million years ago. Before Chang'e 5's glass beads, these irregular mare patches were among the best evidence of recent volcanic activity on the moon. Yet, without confirmation, their origins remain uncertain. And now, the glass beads confirm volcanic action. The findings raise new questions about the moon's inner workings. In particular, how could it retain enough heat to sustain volcanic eruptions? We thought that the moon had cooled significantly after its formation 4.5 billion years ago, which made it volcanically inactive. And without tectonic activity or an atmosphere, the moon should have shed its internal heat long ago. Yet the beads suggest the possibility of some localized heat sources within the moon's mantle. Scientists think that heat-producing elements such as potassium and thorium might be creating small, warm pockets which generate enough heat to melt rock and trigger isolated volcanic eruptions. But wait, beyond rewriting the moon's history, this discovery adds an intriguing twist to ongoing studies of transient lunar phenomena. These sightings, often reported as ghostly glows or hazes by amateur astronomers, remain unconfirmed by scientific probes. Some experts just dismiss them as illusions caused by Earth's atmosphere. But if the moon has small pockets of volcanic or outgassing activity, TLP might have a real basis. Gases emitted from beneath the surface could explain such mysterious glows and possibly be a hint of residual volcanic action on the moon. Now, if volcanic activity still lingers on the moon, this might have exciting implications for future lunar missions. In the coming decades, astronauts might be able to use volcanic heat for generating power, melting ice into water, or even warming bases built into the frigid lunar surface. But recent geological discoveries aren't limited to Earth's natural satellite. We learn more about volcanic moons beyond our solar system too. The detection of a possibly volcanic exomoon orbiting exoplanet WASP-49b around 635 light-years away means that volcanic activity may be a common feature among moons. Up until now, Jupiter's moon, Io, held the title of the most volcanic body we know about. But researchers at NASA's Jet Propulsion Laboratory may have found a new candidate. This potential exomoon came to light when scientists observed a cloud of sodium gas around the exoplanet. But the thing is, sodium clouds are unusual in planetary atmospheres and can suggest volcanic activity. The sodium cloud near WASP-49b had a bizarre, unexpected behavior. It was moving erratically, shifting size and occupying a space too large to be explained by the exoplanet's own atmosphere. Scientists thought the cloud could actually be generated by a volcanically active exomoon in orbit around WASP-49b. Volcanic moons like Io are known to release gases such as sulfur dioxide, sodium, and potassium, which form massive clouds around their parent planets. Io, for instance, regularly produces vast amounts of gas that form a cloud encircling Jupiter, up to 1,000 times the size of the gas giant itself. If something similar occurs near WASP-49b, the gas cloud could be a clue to volcanic activity on an exomoon orbiting the planet. Observations from the European Southern Observatory's Very Large Telescope in Chile seems to confirm this theory. The sodium cloud around WASP-49b is positioned high above the exoplanet's atmosphere and behaves in ways that don't match the exoplanet's 2.8 Earth day orbit. This could suggest that it originates from a separate body, likely a volcanically active moon. Additionally, WASP-49b and its host star consist primarily of hydrogen and helium, which makes the sodium cloud even more unusual. The observed rate of sodium release, over 220,000 pounds per second, can be a sign of an immensely powerful volcanic source. If scientists verify the existence of this exomoon, it would be the first discovery of a volcanic exomoon. Back in our solar system, Io remains the main space object helping us understand volcanic moons. Recently, NASA's Juno spacecraft provided some of the closest images of Io since the Galileo mission over 25 years ago. Io's intense volcanic activity is caused by tidal heating, the result of the gravitational pull of Jupiter and nearby moons, like Europa. This tug-of-war generates immense friction within Io, producing heat that fuels continuous volcanic eruptions. One of Juno's most exciting recent findings was a new volcano that appeared just south of Io's equator. Juno's images show a large, complex volcanic region, approximately 111 by 111 miles in size. The craziest thing? It wasn't there when Galileo imaged the same spot in 1997. This new volcano formed near the previously known volcano Canehekele. Researchers say that this new volcanic structure is a great change that highlights the dynamic nature of Io's surface. Io's equatorial region is home to most of its volcanoes because of the concentrated tidal heating it experiences. The most powerful eruptions emit sulfurous gases and produce bright lava flows. They cover the moon in colorful, sulfur-rich deposits. JunoCam's image, taken from about 1,570 miles away, shows Io dramatically lit by sunlight reflected off Jupiter. And you can see a stunning view of its constantly changing volcanic surface. Despite these detailed observations, there are still many mysteries about Io's volcanism. Scientists are particularly curious about how tidal heating affects Io's interior, and whether it has a subsurface magma ocean. Plus, researchers tried to understand what triggers different types of eruptions. For example, plumes versus lava flows, and how volcanic gases shape Eo's surface and thin atmosphere. The study of volcanic moons from Io to the possible exomoon near WASP 49b sheds light on how tidal forces create volcanic activity in different moons. In icy moons like Europa, tidal heating sustains liquid oceans beneath the surface, creating potential habitats for life. But for Io without an ocean, the same forces instead generate powerful volcanic activity. Plus, if volcanic exomoons do exist, like the one possibly orbiting WASP 49b, we might soon discover more volcanic bodies across the galaxy.
Time can stretch or shrink depending on where you are. Climb to the top of an extremely high mountain, and time will pass a teeny tiny bit faster than if you were down in a valley. That's all because of gravity and how it affects time. We hardly notice it in our everyday life. But for scientists and space agencies preparing to send people to the moon, these minuscule differences in time really do matter. We'll get to answer the why question a bit later. Right now, a new space race is underway. Many countries want to establish long-term bases on the moon. With humans up there, things like reliable timekeeping become crucial. The thing is, the moon doesn't operate on Earth's time. A day on the moon runs slightly faster than a day on Earth. The difference is about 56 microseconds, and it seems insignificant. But over time, even such a difference can add up, creating bigger issues. So, to keep lunar missions running smoothly and prevent things from drifting out of sync, NASA and scientists around the world are now dealing with a tricky challenge, creating an entirely new lunar timescale. NASA is supposed to start using it by 2026. It's the same year they hope to send astronauts back to the moon for the first time in 50 years. But this new timescale is not just a moon time zone. It's actually an entire system that will adjust for the moon's faster time and keep everything synchronized with Earth's time systems. Only in this case will missions be able to run smoothly. You see, on Earth our timekeeping is already surprisingly complicated. It might seem like time should be a straightforward concept, but keeping accurate time is actually a precise science, especially when you consider how much timekeeping affects our daily lives. So, to keep global time coordinated, scientists rely on something called Coordinated Universal Time, also known as UTC. This global time standard is based on ultra-precise atomic clocks that scientists place in separate locations all over the world. Atomic clocks are cool because they measure time based on the consistent vibrations of atoms, so they're super stable and accurate. This helps scientists make sure UTC is the same for everyone everywhere. These atomic clocks also take into account that time moves slightly more slowly the closer you are to the center of our planet. So, atomic clocks positioned closer to the Earth's surface tick a bit more slowly due to stronger gravitational pull. This effect, explained by Einstein's theory of relativity, happens because gravity affects time. By spreading atomic clocks across different elevations, scientists average out all the tiny time differences caused by gravity. Also, for precise timekeeping, scientists occasionally add leap seconds to account for the small natural changes in Earth's rotation speed. It sounds pretty technical, but this process of keeping everyone on the same time helps make the modern world function. After all, precise timing is crucial for global trading, GPS navigation, and even internet communications. But time on the moon works differently. Our natural satellite has a weaker gravitational field than Earth. That's why clocks on the moon tick a bit faster. This difference means that lunar clocks are very likely to slowly drift away from Earth clocks if there's no correction. It can lead to big problems when astronauts need to keep in close contact with Earth or navigate around the lunar surface. NASA's solution is something called a lunar timescale. Scientists aren't going to adjust moon clocks to match Earth exactly. Instead, they want to establish a unique system that measures lunar time accurately, but is also easy to convert back to Earth time. Think of it as creating a whole new framework just for the moon. To make this lunar time system work, NASA is cooperating with international colleagues like the European Space Agency. Together, they're setting up what they call LunaNet. This lunar network will be a bit like the Internet for the Moon. It'll make sure all the lunar clocks work together and align with Earth-based time. Just like how atomic clocks around the world coordinate for UTC on Earth, clocks on the Moon will be part of this larger LunaNet network. Now, scientists are pretty experienced when it comes to managing time in space. Global Positioning System satellites, which orbit Earth about 12,550 miles high, have atomic clocks on board. These clocks tick faster than clocks on the Earth's surface because they're quite far away from Earth's gravitational pull. But then, how does GPS navigation stay accurate? It's because scientists have figured out ways to slow those clocks down to match Earth's time. This experience with GPS clocks is a great base for what scientists need to do on the Moon. In some ways, it might be even easier than managing GPS. Scientists can work with lunar clocks as they naturally are, instead of needing to adjust them to sync perfectly with Earth. By setting up accurate lunar time from the start, scientists hope to avoid some of the complications of managing GPS satellites. And now, here's the interesting part, or maybe more interesting. To keep lunar timekeeping a reality, NASA and its partners want to set up clocks both on the lunar surface and on satellites orbiting the Moon. Some of these clocks will be long-lasting atomic clocks, and others will be crystal oscillators. Those offer stability over short time periods. Together, these clocks will create a network that scientists will be able to rely on. Meanwhile, atomic clocks for space don't come cheap. They can cost a staggering few $1,000,000 each. Luckily, crystal oscillators are more affordable, but they don't stay accurate over long periods. Once those clocks are set up, they'll work together as part of LunaNet, which will be NASA's framework for everything related to moon-based time and data networks. LunaNet will act like an internet for lunar operations. Different space agencies will contribute to it, like how internet service providers work for us on Earth. But there's another set of challenges, and it's connected with the Moon's rotation. Firstly, a day on the Moon lasts much longer than a day on our planet because it takes the Moon about 28 Earth days to make a full rotation. Plus, the Moon's equator experiences about 14 days of sunlight, followed by 14 days of darkness, unlike Earth's regular day-night cycle. And at the Moon's south pole, where NASA is going to establish future lunar missions, there are areas that stay lit or in shadow permanently. It might make it harder for astronauts to keep track of time. NASA and its partners hope to involve more countries in this project through international organizations like the International Astronomical Union. The idea is to get as many countries as possible on board with the lunar timescale, so that everyone exploring the Moon is on the same page. Now, another really exciting thing about all this is that figuring out lunar time could help other future space missions, like trips to Mars. The experience and knowledge we'll get from setting up a lunar timescale are likely to serve as a blueprint for managing time on even farther planets. That's one of the reasons why scientists are taking this lunar project so seriously. As for astronauts living on the Moon, a consistent, reliable time system will be essential, not just for navigation, but for everything from scientific experiments to day-to-day activities. NASA's Lunar Time Project is truly groundbreaking. It's the first step toward managing time as humans expand farther into space. And if they get it right, it'll mean that future astronauts won't just have Earth time to guide them. They'll also have a Moon time, and even, one day, a Mars time too. Precise timekeeping matters both for the sake of scientifically understanding the passage of time on the Moon and for setting up all the infrastructure necessary to carry out missions. Scientists are also eager to create a timescale from scratch because they can take everything they've learned about timekeeping on Earth and apply it to a new system on the Moon. Well, I'm out of time, so bye! There's something happening inside the Moon, something that nobody expected. Not a dramatic shift you'd see on the outside, but deep down, where things seem frozen in time, scientists have uncovered a hidden layer of what you could only call moon goo. Remember those school lessons about the crust, mantle, and core? Much like the Earth, the Moon is made up of layers, a crust, mantle, and core. However, the Moon's core is much smaller compared to ours. Earth's core is huge. It makes up about a third of our entire planet's mass. The Moon's core makes up only about 1 to 2% of its mass, and its diameter is about 1/5 the diameter of the Moon itself. It's surrounded by a hard, rocky mantle, but it turns out that between these two layers, that mysterious goo layer, and it's way more important than you might think. The layer is soft and partially molten, ebbing and flowing like the tides in our oceans. It rises and falls, stretching and shifting as if it were alive. Its movement isn't chaotic, but subtle and regular. We always knew that the Moon influences our seas and oceans, causing tides with its gravity. But it turns out that we influence it back. The goo ocean reacts to the gravitational dance between Earth and the Sun. Also, the molten layer could be made of ilmenite, a very intriguing material. Ilmenite is rich in titanium, a strong and lightweight metal that we really love over here on Earth. Titanium is used in everything from airplane parts and spacecraft to medical devices, even in everyday items like bikes and laptops, all because it's incredibly strong and very resistant to corrosion and heat. So, if the Moon might have a molten layer rich in ilmenite, that would be awesome. Astronomers are already planning for lunar bases, and if we had a material to build structures, spacecraft, or even tools for astronauts right there, that would be a game changer. Otherwise, we'd need to transport materials from Earth, which is extremely costly. This is our first tangible sign that the Moon is not just a cold, boring rock. Instead, it's dynamic, living, and breathing, with moving forces beneath the surface. NASA used new special tools to discover this: the Gravity Recovery and Interior Laboratory and the Lunar Reconnaissance Orbiter. These are both space missions designed to study the Moon, but they don't just look at the surface like a telescope. Instead, they help measure things we can't see with our eyes, like the Moon's gravity and how it changes over time. Grail sent 2 small spacecraft around the Moon named Ebb and Flow. Clever. The idea was for these spacecraft to fly close to each other and measure tiny differences in the Moon's gravity as they go. It's like they were feeling the Moon's invisible pull in different places. If the Moon's gravity was stronger in one spot, the spacecraft moved closer together, and if it was weaker, they moved farther apart. This helps scientists understand what's going on inside the Moon, even if they can't actually go there. And the spacecraft intentionally crashed into the Moon in December 2012 to end the mission. The Lunar Reconnaissance Orbiter is a bit different. It takes super detailed pictures of the Moon and collects other important information about its surface. By combining the information from both Grail and LRO, we were able to find this goo layer. But this discovery actually challenges everything we thought we knew about lunar geology. How did this molten layer get there? How long has it existed? And perhaps more fascinating, how it stayed warm for millions of years. That's some million-dollar questions. The Moon's core generates heat just like ours, but it's not as easy as saying, oh, the core's heat probably keeps it warm and molten. Well, first, the Moon's core is much smaller and less active than Earth's, meaning it produces significantly less heat. Plus, the Moon is much cooler than Earth in general. With temperature dropping to minus 200 degrees Fahrenheit on the surface, how could this inner layer still stay in this flowing state? That's still a mystery. In any case, this goo could actually explain a lot of stuff about the Moon. For example, astronomers were exploring moonquakes and how they happen. Now they think that it might be this semi-molten layer shifting and moving beneath the surface. Now, beyond the Moon itself, it also tells us more about other celestial bodies. If the Moon, something we considered basically a huge static rock, has such a dramatic life, what about other planets, moons, or asteroids? Could they also hide similar hidden movements beneath their surfaces? We can even understand our own planet better, learn more about how tides and similar stuff works. There are so many great discoveries we've been making on the Moon. Recently, we found some awesome stuff beneath the surface, massive caves hidden for millions of years. For over 50 years, scientists have suspected that the Moon's surface is full of underground tunnels and caves. These are known as lava tubes because they were formed by lava. Duh! Millions of years ago, the moon was pretty unstable. It underwent some volcanic activity, causing eruptions. When a volcano erupts, lava can flow across the surface. As the outer layer of the lava cools and hardens, it forms a solid roof of dark material. It's actually what these famous dark spots on the moon are. These are dark, hardened remains of ancient lava. But the hot, molten lava continues to flow through the center. Once the eruption ends and the lava drains away, what's left behind is an empty hollow tunnel, hence a lava tube. On Earth, we have lava tubes in places like Hawaii or Iceland, where volcanic activity has created similar underground tunnels. The same thing happened on the Moon billions of years ago, although they're much crazier compared to ours. In fact, lunar lava tubes are now thought to be some of the largest and longest in the entire solar system. One such cave was discovered beneath the famous Mare Tranquillitatis, the place where Apollo 11 first landed, and it's at least 340 feet deep. Now, all these lava systems have remained hidden just beneath the surface, untouched for millions of years. Only now, they finally managed to prove their existence. Scientists from the University of Trento in Italy found them using special radar technology and advanced computer methods. These techniques let you see underground by sending radar waves. The waves bounce back and give clues about what's hidden underneath. By analyzing the way these waves reflected back, the researchers could detect the shape and size of the hidden caves. Now, the best thing about this discovery is that we could build all our bases there. These caves protect from radiation, harsh winds, and meteoroids. NASA even found evidence that some of these caves stay at a steady 63 degrees Fahrenheit. That's some crazy coziness for the moon. And on top of that, there could even be some water there. So humans could take shelter inside these natural tunnels and build entire colonies on the moon. And I know what you're thinking. Could unexpected lunar monsters hide deep in those caves? Well, sure. There's a huge potential for exploring these caves and finding some awesome stuff. But even if we manage to find a miracle, like small life or microbial organisms, there's a 99% chance that there won't be actual animals or monsters. It would just be impossible for them to develop in such conditions. But it would make a great horror movie. Researchers want to send robots or drones to explore the tunnels first, and then see if they're safe enough for humans. And it's not just the US getting in on the action. China is also investigating the possibility of using these moon caves as a future base, showing that the race to explore and settle the moon is heating up. This catapult-like system on the moon might bring us limitless energy. It's a launch system concept that was recently proposed by the Chinese scientists. It would work like a hammer throw, spinning a launch arm that flings objects. This arm is supposed to be about 165 feet long. It will accelerate until it reaches the moon's escape velocity, and then whoosh, the capsule is sent into space. This crazy idea will cost around $18 billion. Ooh, pricey. But trust me, it's totally going to be worth it. The system would be powered by solar panels and nuclear energy. It could also recover more than 70% of the energy used after each launch. The moon has a very weak gravity. There's also barely any atmosphere, so the air doesn't weigh you down. This makes it so much easier to launch stuff there. But why do we even need this? The main purpose is to transport helium-3. It's a really cool isotope of helium, and one of the most insane things about it is that it could become fuel for nuclear fission. This is the same process that happens in stars, including our Sun. If we manage to recreate nuclear fusion here, on Earth, we can make it a clean and basically limitless source of energy for power plants. But helium-3 is super rare on Earth. We can sometimes find it in volcanic rock formations on the ocean floor. That's because it's a product of another rare element called tritium, the element we usually make in nuclear reactors and put in cool stuff like glow-in-the-dark paint. But the catch of tritium is that it takes forever to decay and turn into helium-3. Now, there's a bunch of helium-3 on the moon, around 1 million tons. Just 20 tons of helium-3 could meet China's yearly electricity needs. In fact, lunar soil has enough helium-3 to power the entire world for over 1,000 years. But why is there so much of helium-3 on the Moon and barely none on our planet? Well, that's because helium-3 comes from the sun and travels in solar winds. Solar winds are like streams of dangerous particles. They're super radioactive. Our planet's thick atmosphere and magnetic field serve as a shield for us. They almost fully protect us from those particles. But, unfortunately, they also prevent the good stuff like helium-3 from getting here. The Moon's atmospheric shields are super thin though, so it's under a constant shower of solar winds. So, helium-3 accumulated there over billions of years, and now it's just scattered around there. But mining it and bringing back to Earth is no easy feat. It's super expensive. Just think about it. Rockets need tons of fuel to break free from gravity. Every single bolt and screw on the spacecraft must be engineered to survive extreme conditions, like radiation. Not to mention, you need a team of rocket scientists, literally working around the clock to make sure nothing goes wrong. You can't call a repair guy if something breaks on the Moon. So generally, it costs about $500,000 to send 1 pound of payload to our satellite. That's based on estimates from NASA. To get some idea, let's calculate how much it would cost to send an apple to the Moon. A typical apple weighs about 0.4 pounds, so that funny mission would be at least $200,000. Now, for comparison, the Chinese launch system weighs around 80 tons. Another problem is that the lunar surface is pretty harsh on the equipment, like the freakish lunar dust, for example. You might recall this small thing that happened in the 60s called the moon landings. But when the Apollo astronauts came back from the Moon, they found something weird was happening to them. Their throats were sore and their eyes wandered. Luckily, it wasn't some scary moon sickness. Turns out, there's a lot of lunar dust clinging to their spacesuits. This dust seems harmless, but it's made up of sharp and abrasive particles, much smaller than a human hair, yet sharp like glass. It contains silicate, a thing that can cause severe lung problems on Earth and is a common issue for miners. So it caused a lunar hay fever. At least that's how NASA astronaut Harrison Schmitt called it. All 12 astronauts who walked on the Moon were then sneezing and experiencing nasal congestion. Sometimes it took days to fade away. The dust even got inside their spacecraft, smelling like burnt gunpowder. This nasty stuff can be harmful to both humans and equipment. It managed to damage spacesuit boots and even ruin the seals on the containers used to bring back samples during the Apollo missions. As we mentioned, they're glass-sharp and jagged, so they start scratching, grinding, and wearing down any surfaces they come in contact with. They don't care if it's metal, glass, or humans. And since there's so much dust, this causes equipment to malfunction and fail quite quickly. And that's just one of the possible hurdles with lunar missions. So scientists really need to come up with some weird ideas to get that precious helium-3. The Chinese scientist project looks like a weird sci-fi invention, but it's a cost-effective way to transport materials back to us. It could throw stuff to Earth twice a day, and it would be 90% cheaper than current methods. Since it only needs electricity and no fuel, the system would be small and easy to set up. Besides the beloved helium-3, this catapult would also help advance technologies in space mining and heavy launch vehicles. No lunar dust scares this thing. It should last for at least 20 years. It would need to be transported to the Moon using China's super heavy lift rocket. But the idea is far from new. There was a novel called The Moon is a Harsh Mistress by Robert A. Heinlein. In the story, there's a lunar colony that uses an electromagnetic catapult to send weed and water ice back to Earth. It gets quite wild when the colonists, known as loonies, eventually take control of this catapult. They threaten to launch rocks at Earth unless their colony is recognized as an independent world. Sounds kind of funny, but a large rock, if thrown at us from the Moon, could wipe out a city. The damage would be like from a meteorite strike, with fires, houses destroyed, and worse. But scientists have been talking about this catapult idea for a while. For decades, they were trying to find a way to use electromagnetic systems to send resources from the Moon to Earth. There are also some challenges. For example, scientists forgot to mention how exactly helium-3 would be extracted from the lunar soil. Installing this launch system on the moon's rugged surface would be difficult as well. Also, they would need to make sure that the system remained stable at high speeds and that it could withstand the moon's extreme temperature changes, cosmic rays, and intense solar radiation. So, it would take some time to develop. China hopes to have the key components of the system ready by 2030. The full-scale operations might start by 2045. China has tons of plans for the moon. For example, they want to build a research station at its south pole by 2035. But China's not the only one in this space race. Considering that NASA plans to send humans on Mars by that time, oh boy, the 2030s will be a crazy decade for space exploration. There's also an American startup that's part of the lunar economy. The ones that plan to land astronauts on the moon have people actually living on our satellite in a decade or two. One of the goals of this colony is to boost economic growth and create new jobs. Most of them will likely involve some mining activities. And if there'd be 2 space colonies, well, they'll have to figure something out.
An asteroid broke off the moon and now it's super close to Earth. Does it pose a danger to us? Kama'oalewa, also known as 2016 HO3, spins super quickly as it orbits near our planet. Let's call it HO3 for short. Astronomers found it on April 27, 2016. Compared to other asteroids, it's tiny. On Earth, though, it would be the size of a small building, or about half the size of the London Eye Ferris wheel. They discovered it in Hawaii, and its name roughly translates to a fragment of something that seems to wobble. After some study, they realized that this asteroid might be a chunk of the moon that got blasted into space. There's a part of the moon called Giordano Bruno crater, named after an Italian philosopher, that guy who had to pay quite the price for his ideas. If you look at it from space, Giordano Bruno stands out because it's surrounded by some rays of material. They're super huge, stretching over 93 miles and are still bright. This means that an enormous boom once happened there. There's an interesting story about this. In 1178, 5 monks were traveling in Canterbury, England. Suddenly, they saw something strange happening on the moon. They said it looked like the moon was splitting, with flames and sparks. Then there was a darkening that spread all across the lunar surface. In the 20th century, scientists found these records and thought that these monks saw the formation of the Giordano Bruno crater. But later it turned out that the crater's about 4 million years old. And thank the stars, because such a massive impact, if it really happened in the 12th century, would have gone crazy on our planet. It would have caused a huge meteor storm on Earth. In any case, our HO3 is most likely a piece of the moon that broke off during that impact 4 million years ago. Luckily, there's no need to panic about it. When astronomers spotted this sudden moon piece, they quickly tracked its orbit. Turns out, it won't collide with us anytime soon. It's going to be our quasi-satellite for at least 300 more years, meaning it'll follow a path around the Sun that keeps it close to Earth without colliding. Its orbit is wild, though. It seems to be constantly looping around our planet in some pretty unique loops, moving closer and going away, up and down. And then somewhere in the 24th century, it will go even more crazy, switching to a horseshoe orbit, slowly going away from us. Could HO3 collide with us someday? Maybe, but that would happen over millions of years, when it would leave its current orbit and collide with Earth, Venus, or even the Sun itself. Or maybe entirely ejected from the solar system. Even though it's one of the closest asteroids ever discovered, it's also one of the smallest and most stable ones. This discovery also opens up some exciting ideas about life in the universe. We see that rocks can travel between celestial bodies. There is a theory that life could have been spread all across the universe by traveling on these rocks like on some space Ubers, or at least the building blocks of life like carbon. Maybe life even hitchhiked to our planet on rocks from Mars. HO3 probably doesn't carry any life, but the fact that it can travel for millions of years carrying stuff on it and feeling fine supports this theory. Astronomers want to send something to investigate HO3. Back in 2017, a group of students gave an idea of using a spacecraft for it. The China National Space Administration wants to send a robotic probe to HO3 somewhere in 2025. The robot should fly there, collect samples, and bring them back to Earth for study. Unfortunately, you can't see this asteroid in the sky with the naked eye. Its size is about 130 to 330 feet in diameter, so it would be too tiny and dim to see without a super powerful telescope. But there is an asteroid that you'll be able to see, and it will be insane. In 2029, a large asteroid will pass so close to Earth that it will be visible to the naked eye. Make sure not to miss it, because this is a once-in-a-thousand-year event. The asteroid is known as 2004 MN4, or Apophis for short. It's much bigger than HO3, about 1,210 feet wide. This will be the closest asteroid passage ever. This one actually caused some panic back in December 2004, all because there was a 2.7% chance that it could hit Earth in 2029. People were horrified. Even the name, Apophis, is inspired by an evil serpent from ancient Egyptian mythology. A huge monster that fought Ra and always tried to swallow the sun and destroy the planet. Luckily, when scientists got more data, they realized that it would pass pretty close to us in 2029, and we'd be able to see it in the sky. But then, it will just fly away like a chill asteroid. There was another worry though. That during its close pass, Apophis might travel through something called a gravitational keyhole. Basically, that it could travel through a specific narrow region of space which would accidentally alter its orbit. And then it would make an epic comeback in 2036, like the planet from the movie Melancholia. However, after some calculations, scientists ruled out this possibility as well. Apophis will still come quite close to us in 2036, but it will be about as far away as Venus is when it overtakes Earth. And then, Apophis and Earth will just go their own separate ways. On average, an asteroid the size of Apophis is only expected to hit Earth once every 80,000 years. And if it did hit us, it would completely destroy a huge area, causing earthquakes and tsunamis all around the world. But it wouldn't cause an apocalypse or anything like that. You'd only be able to see Apophis from Europe, Africa, and Western Asia. So if you want to see it, you might need to travel. The asteroid will look like a fast-moving star in the night sky, shining bright enough to be seen without any special equipment. It would be easy to spot at night, though city lights might make it harder to see. Now, can you imagine that these are not the only guys hanging nearby? Both HO3 and Apophis are part of the so-called Apollo orbit asteroids. These are the asteroids with orbits going around Earth, an entire group of dangerous fellas. Since they cross Earth's orbit, they have the potential to come close to or even collide with our planet. The first asteroid of this group to be discovered was 1862 Apollo, named after the Greek deity of the sun. It was first discovered in 1932, and the group was named after it. This one was even bigger, almost a mile in size. In fact, it's so huge that it even has its own tiny moon. Apollo crosses orbits of not just Earth, but also Venus and Mars. Fun fact, even though it was the first one of its kind, telescopes accidentally lost it out of view for over 40 years. So scientists went, oh well, let's just keep the count of things we can see. When Apollo was rediscovered in 1973, it wasn't the first asteroid on the list and got a big number in its name. Apollo will fly near us during the next hundreds of years. In 2075, it will be somewhere around Venus, but it should fly by as well. In any case, there's no need to worry, because astronomers are keeping a close track on these guys. If we were in any immediate danger, we'd have known. In order for an asteroid to totally destroy life on our planet, it should be bigger than 6 miles in diameter, like the one that helped to wipe out the dinosaurs 66 million years ago. But these guys are so crazy rare, we'd probably live on other planets by the time they arrive on Earth.
So, you want to get as close to the moon as possible without leaving Earth? Easy. Hop on a plane to Ecuador and climb Mount Chimborazo. I know, it may sound weird, but hear me out. Now, Everest is the tallest mountain when you're measuring from sea level, but Chimborazo's peak is actually the closest spot on Earth to the moon. Here's the physics behind it. Mount Everest is over 29,000 feet tall, and Chimborazo is only around 20,000 feet. But the secret lies in how far they are from the Earth's core. You see, Earth is not a perfect sphere. It's chubby in the middle and slightly squished at the top and the bottom. The chubby part in the middle is called the equator. FYI, the country Ecuador actually translates to equator in Spanish. Now you know. The mountain we're talking about, Chimborazo, is located a few degrees from the equator line. So since the squishy sphere is chubbier in the middle part, Chimborazo's peak sticks out farther into space. This means that if you hike all the way up to this mountain's peak, you'll be a smidge closer to the moon than if you hike all the way up Mount Everest. In the North Sea, off the coast of England, there's a tiny platform bobbing around, roughly the size of 2 tennis courts. You might think it's an oil platform, but this is Sealand, the world's tiniest country. The Ruff's Tower platform was built during the first half of the 20th century as a fort to protect English ships. Jump to the 1960s when a guy named Paddy Roy Bates decided to claim this old fort as his own country, naming it the Principality of Sealand. Paddy gave his country everything it deserved: a national flag, currency, a constitution, stamps, and a hoisting swing system. That's how you get into the country, by the way, hoisted all the way up to the upper part of the platform. Today, this micronation is headed by ruling monarch Michael Bates, who is a member of the country's self-proclaimed royalty. I know, right? Why wait in line for the British throne? The nation has its own fan club, who cheer for the country's national soccer club. Their team competes in international tournaments where they usually play with other tiny nations. Although Sealand only has one official resident as of right now, players from other countries join to help out their soccer team. One of the country's supporters also placed a Sealand flag on top of Mount Everest. Having your kitchen in one country and your living room in another, well, this is the daily reality for some locals in Barle. In this town, the border between Belgium and the Netherlands doesn't just run along streets, it slices right through buildings. So, to navigate this setup, a rule was made that a house's nationality is determined where its front door is located. But this solution created its own problems. There's a house where the front door is exactly on the border, giving it 2 addresses, one in Belgium and one in the Netherlands. The owners of this house were given a unique opportunity. They could choose which country they'd like to get their utilities from, like gas and water. And you guessed it, they picked the country where the stuff was cheaper, in this case, Belgium. Down in Senegal, Africa, there's a lake that looks like something straight out of a sci-fi movie. About 18 miles north of the capital, Dakar, you'll find Lake Retba, also known as Lac Rosa. This lake is famous for its bright pink water. Yes, it really is pink, and you can even take a swim if you're up for it. But be prepared, the water is super salty, one of the saltiest lakes in the world with salt levels over 40%. The pink color comes from a species of tiny algae. These algae produce red pigments that reflect sunlight, giving the lake its unique shade. If you want to see the lake at its brightest pink, visit during the dry season from November to June. The rainwater during other times of the year can wash away some of the color. Oh, by the way, there are other pink lakes around the world, like Lake Hillier in Western Australia and Lake Natron in Tanzania. So there's a hill that seems to be on fire all the time. Located in the Arctic region of Canada, the Smoking Hills are a truly unique sight on Earth. Some of the minerals found here are so rare that they've only been spotted on Mars. For at least a couple of hundred years, the ground here has been smoking continuously. At first, explorers thought this was due to an active volcano, but it turns out the smoke comes from something else. The soil in the Smoking Hills contains sulfur and coal, and when these materials mix with oxygen, they can spontaneously catch fire and keep on burning. But don't get any adventurous ideas about visiting. The environment here is extremely harsh, there's toxic smoke, and the temperatures can be dangerously high. So, I'd try Orlando. New Zealand is famous for its stunning landscapes, but it also has a hidden treasure underground. Deep in some caves in the country's North Island, you can find a mesmerizing natural wonder. To see it, you'll need to go down about 150 feet in a series of dark, twisting caves. As you go deeper, you'll enter complete darkness until you reach the cave ceilings, which are lined with tiny glowing creatures. These are New Zealand's native glowworms, which are the larvae of a special type of fungus gnat found only in this country. They shine a bright blue light to attract prey. If you get a chance to tour these caves, it feels like floating through a galaxy, with thousands of these living stars sparkling above and their glow reflecting in the water beneath your boat. It's an incredible sight, like stepping into a magical glowing world. Mexico is home to one of the most amazing caves in the world, called the Cave of Crystals. If you think you've seen big crystals before, wait until you see these. In around 1910, miners in the town of Nica, Chihuahua, yeah, like the dog, discovered a cave full of clear selenite crystals. But it wasn't until 90 years later that they found an even more incredible cave filled with enormous crystals, some as long as 39 feet and weighing up to 55 tons. Scientists believe that 26 million years ago, give or take, hot, mineral-rich water filled this cave, allowing these huge crystals to grow. The Nica crystals are thought to be the biggest in the world, making people standing next to them look teeny in comparison. However, exploring the cave isn't easy. Inside, temperatures reach 136 degrees Fahrenheit. Even with protection, people can only stay inside for 20 to 30 minutes. It's an extraordinary place, but not exactly a comfortable one for humans. Mauritius is famous for its beautiful beaches and clear blue waters. But it also has a stunning optical illusion at its southwest corner that looks like an underwater waterfall. Even though it seems like water is flowing down into the ocean, what you're actually seeing is a trick of the light and the seafloor. The island is on an ocean shelf that's only about 500 feet deep, but just beyond the edge, it drops down to 2.5 miles deep. This drop creates the illusion of a waterfall as currents push sand and particles over the edge, making it look like water is cascading down. So, while it's not a real underwater waterfall, it's definitely a cool sight to see from a boat. Now here's a place that might either give you chills or leave you in awe, depending on when you visit. Near the small town of Gryfino in Poland, there's a forest of pine trees with a strange twist. They're all bent at their bases. During the day, these trees with their sharp 90-degree curves look fascinating and even a bit whimsical. You might even find a comfortable spot to sit on if you're having a picnic. But visit the crooked forest at night, and it takes on a whole different vibe. A thin layer of fog hangs around, making the forest look eerie and a bit spooky. Plus, scientists still don't know why for sure the trees are bent like this. So, would you prefer to see it in the bright light of day or the mysterious dark of night? Ooh. So, Mars has several faces. No, really. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted something interesting, a big structure that looked like a human face. It was in the region called Cydonia. It soon became very popular. A bit later, we also discovered the so-called crown face in Libya Montes. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, like something from an ancient Egyptian tomb. A lot of people hyped that story up. The image was shared widely on social media, making the crack look bigger than it really is. Some people think that it's hinting at extraterrestrial life. But after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The crack formed naturally over time, maybe from wind erosion or Mars quakes. Mars is a gold mine of mysterious structures. Recently, we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or ice. These lava coils are shedding light on that mystery. Now, thanks to high-resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. What's fascinating is these lava coils are like the ones we see on Earth, like those formed by Hawaiian lava flows. These spirals are so well preserved that they were easily overlooked before. They range from 16 to almost 100 feet wide and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle. We still don't know much about those. But Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern. It's about 9,000 miles long, making it larger than the diameter of Earth. It's thought to be a jet stream made of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 80s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from blue to golden over time. There are different ideas about why Saturn has this thing. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with the bizarre moons. One of them is called Lapidus. This moon has a weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. Where's my nutcracker? This ridge is incredibly tall by our standards, around 8 up to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the moon's surface and is considered the third largest mountain range in the entire solar system. Now, we don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons. There's one idea, though. The ridge might be the remnants of a dead moon. Let's say billions of years ago, a colossal impact shattered chunks of material off Lapidus. These pieces circled around the moon, forming a mini-moon or sub-satellite. And over time, the gravitational pull of Lapidus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Lapidus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because, luckily, Lapidus was quite far away from it. If Lapidus was closer to Saturn, its moon might have been pulled away. But we do need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on in its methane seas. Scientists have spotted these strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem. In water, molecules stick together, which is why stuff can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet, these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this holy ice come loose from the edge of the lake, they can float on Titan's seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by wind. We need more research to know for sure. Moons like to be weird. Just look at our own one. In 1971, we found a patch with missing soil on our moon, and it looks like a blue lake. They call this mysterious spot Ina. We first spotted it during the Apollo 15 mission in 1971. Later, the Apollo 17 mission took clearer pictures of it. This spot, shaped like a bluish D letter, is one of the weirdest things on the Moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Ina. Ina is unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. It's similar to the surface age of the volcanic field that surrounds Ina. Now, our Moon has its own face, just like those on Mars. There's an area near the Moon's south pole that looks like a face, but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the Moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. Well, that's because our brains are wired to recognize faces, even when there aren't any. It's a phenomenon called pareidolia. Our brains try to make sense of shapes, so when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes like Mickey Mouse. So don't worry, it's not extraterrestrial life. It's our brains that play tricks on us, making us see familiar shapes like faces even where they don't really exist. Now, don't get all upset, but the Moon is shrinking and getting wrinkled, pretty much like a grape turning into a raisin. That happens because our natural satellite has been retaining its inner heat for over 4 billion years, but its core is gradually cooling down and becoming more dense, like me. Unlike a grape's flexible skin, the Moon's surface is pretty brittle. This brittleness causes faults to form where different sections of the crust push up against each other, leading to what scientists call moonquakes. So far, our satellite has shrunk by around 150 feet in circumference. It's such a tiny change that it won't affect the look of eclipses or the phases of the Moon. Even tidal cycles won't be affected since the Moon's mass hasn't really changed. The shrinking process won't directly affect us down here, but that doesn't mean that all humans are safe. Moonquakes, caused by the shrinking process, have been a concern for years. During the famous Apollo missions, NASA astronauts left seismometers at different points on the Moon. Those are devices capable of identifying seismic activity on the lunar surface with exceptional precision. The equipment was operational for several years, and it managed to capture over 12,000 moonquakes, ranging in magnitudes from 2 to 5. Up until 1977, the team was able to identify 4 distinct types of quakes. Some tremors, like those caused by meteorite impacts, were relatively easy to identify. But the cause of the so-called shallow moonquakes remains a mystery to scientists, and that can be an obstacle to future missions on lunar soil. As the name suggests, shallow moonquakes occur relatively close to the surface, typically between 30 to 135 miles beneath the surface. Recent research suggests that these tremors are triggered by the compression of the Moon's surface, leading to the formation of thrust faults, where one surface layer is pushed up over another. This study also discovered where the epicenters of the strongest ones were. It all started in the South Pole region, precisely where we want to settle down. Interest in the lunar South Pole peaked in 2023, when India's Chandrayaan mission successfully landed and deployed a rover to explore the area. NASA also has plans for the same spot. And their ambitious goal is to take astronauts there for the very first time. The Artemis 3 mission, scheduled for 2026, currently has 13 potential landing spots at the South Pole, represented by the blue squares here. One of the options is situated within a geological feature called the Gerlach Rim 2, which is a strategic area for exploration. It might have ice, because parts of it are completely in the dark, but it's close enough to areas that do have sunlight, which is crucial as a source of power. Now, take a look at the pink dots on that same map. They represent possible epicenters of the strongest moonquakes recorded by the Apollo missions. That means that thrust faults in the area could be relatively young and potentially active, representing a real danger to the Artemis 3 crew. These astronauts will journey to lunar orbit over the course of 30 days, and 2 crew members will descend to the surface, spending about a week at the South Pole. Their moonwalk will be particularly challenging, given the extreme temperatures of these permanently shadowed regions. The presence of moonquakes and possible landslides only adds more danger to this mission, as this phenomenon is far more frightening than earthquakes. The strongest moonquake ever recorded had a magnitude of 5.7. You might think that's not a big deal, considering that countries like Chile, Colombia, and Papua New Guinea experienced earthquakes of similar magnitude in 2023 without significant damage. But the gravitational pull on the Moon is relatively weaker than on Earth, so what feels like a gentle tremor on our planet might be a real ground-shaking event up there. This happens because you're not as firmly connected to the surface of the Moon as you are on Earth, meaning that seismic waves can cause the surface to move more freely. There's also a huge difference in duration. Earthquakes typically last between 10 and 30 seconds, with some lasting up to 2 minutes. A moonquake can persist much longer than that. Our satellite is essentially a solid, rigid, and dry sphere, so when a tremor shakes the Moon's surface, it resonates powerfully without any natural means of dissipation. Moonquakes can last for a good 10 minutes, or even longer, with little tremors sticking around for hours afterwards. Now, these new findings about shallow moonquakes won't actually change the potential landing sites for Artemis 3, and they won't affect the duration of the mission either. That's because accurately estimating how often a specific region experiences these tremors is tricky and unpredictable. What scientists do know is that these shallow quakes aren't very common and pose a low risk to short-term missions on the lunar surface. But that situation changes completely if we consider long-term habitation on the Moon, and that could happen sooner than we expect. The Artemis 3 mission represents an important first step towards space colonization. China is also making the first moves to establish a permanent lunar base at the South Pole by 2040. Their strategy involves utilizing 3D printing and brick production from lunar soil for constructing the moon base. That definitely sounds fascinating, but putting together a setup like that comes with a bunch of challenges, including dealing with intense cosmic radiation, the lack of water, and of course, long-lasting moonquakes. Over billions of years, the surface of the Moon has been hit by asteroids and comets, causing bits and pieces to constantly break off from the impacts. Because of this, all the surface material is pretty loosely packed, so when there are quakes, slopes in the same area can become susceptible to landslides or new faults opening up. Future settlements located too close to these unstable slopes could put everyone living inside these lunar bases at risk. Moon dust adds another layer of complexity because, without erosion or water to smooth it out, it can harden to the point of being as tough as glass. If we really want to understand how dangerous moonquakes might be for people living and working on the Moon in the future, space agencies still need to map out and get new seismic data, and not just from the South Pole, but from the entire satellite. In 2025, the Farside Seismic Sweep Mission, or FSS, plans to deploy 2 of the most high-precision seismometers ever built to the Schrödinger crater, which is located on the dark side of the Moon. Finding out what's happening on the ground there is crucial for understanding the complex lunar structure and its internal dynamics. Scientists are still trying to figure out whether the lack of recorded seismic activity on the far side of the Moon is due to current instruments not being capable of detecting it, or if it's due to some kind of interference from melted material in the mantle. Once they have this answer, it will be easier to fully understand the phenomenon of shallow moonquakes and assess their implications for future neighborhoods on our natural satellite. Now, you may have heard that Earth is also shrinking, but it's a different process. Basically, the Moon is getting smaller mainly because its core is cooling down naturally. The Earth's core is cooling too, but our planet got its crust with tectonic plates, unlike the Moon, which only has one plate. So the energy from Earth's core shifts those plates around or comes through volcanic eruptions. Earth is actually losing mass overall due to atmospheric loss. Our planet loses about 100 million pounds of mass per year, mostly from a leaky atmosphere. Earth's gravity isn't strong enough to retain the lightest particles, like hydrogen and helium, which escape into space. But don't worry, these numbers aren't cause for alarm, considering that our planet's atmosphere weighs about 5 quadrillion tons, a number I can't even imagine. So, in other words, it would take many, many, many times the current age of the universe for it to completely evaporate. Well, that makes me breathe easier. How about you?
The moon is rusting, and chances are it's happening because of Earth. You'd say that since they're more than 230,000 miles apart, they can hardly directly influence each other in such a way, but they do actually have a special connection. The moon affects our home planet as well, and you can see it while observing ocean tides. As Earth rotates, the moon's gravitational force pulls the water on the nearest side of Earth. It creates a bulge. At the same time, another bulge forms on the opposite side because our planet rotates and it causes a centrifugal force. And then, the planet continues to rotate underneath these bulges, which is why we have 2 low and 2 high tides every day. Plus, the moon wobbles every now and then, tilts more or less, and causes changes in ocean tides. And in return, Earth's atmosphere is making our satellite rusty. Rust is that reddish substance you see on old gates or nails. Oh, and you know Vermilion Cliffs and the Grand Canyon? They also have that specific red color, thanks to rusty iron in the rocks. It forms when iron reacts with oxygen and water. Rust is common even on Mars. The planet's trademark color comes from the rust that's been there for a very long time. That's how the red planet got its nickname in the first place. Normally, you wouldn't say the moon is a place that would rust that easily since it's dry and doesn't really have an atmosphere. But a spacecraft studied the moon back in 2008 and detected spectra, wavelengths of light, that were reflecting off different surfaces of the moon. That's why it could analyze the lunar surface better. The data it brought showed that the lunar poles had different compositions than the rest of the moon. They had rocks that contained a lot of hematite. That's a specific type of iron oxide, or simply rust. No one expected that because there shouldn't be so much rust on the moon, considering the conditions there. But we know that there's some water up there on the surface of our satellite. That's why a few new theories popped out about different materials the moon could be hiding. It's possible that they formed because water had reacted with the rocks. For iron to get this rusty hue, it needs something we call an oxidizer. That's a molecule that removes electrons from materials like iron, such as oxygen. But the solar wind keeps hitting the moon all the time, and it brings hydrogen with it. And hydrogen has the opposite effect. It gives electrons to other molecules. Earth has its shield from the solar wind. It's our magnetic field. But the moon doesn't have such protection, and because of that, rust shouldn't be able to form on its surface. But this process still happens, and it could be Earth's fault. The moon itself doesn't have an atmosphere that could provide enough oxygen for iron to rust. But apparently, our planet is generous enough to donate some of its own atmosphere. The oxygen from our atmosphere travels all the way to the moon, following something called magnetotail. That's a long extension of Earth's magnetic field, which can reach the near side of the moon. That's exactly where most of the hematite was found. And during a full moon, the magnetotail blocks 99% of the solar wind, which would normally influence the moon more. It's like there's a temporary curtain over its surface, which gives enough time for rust to form. But there's still one important thing necessary for the appearance of rust: water. It's not like you can find water that easily if you decide to take a walk across the moon. Most of it is frozen and hidden in areas that always remain in cold shadows. Those spots are far away from where most of the hematite was discovered. so it's hard to tell how the water got there. But there's an interesting idea. All those dust particles that hit the moon might be freeing free molecules of water that are locked in the surface layer of the satellite. This is how water ends up mixed with iron. We don't know exactly what these dust particles consist of. They might be carrying some water too. As they hit the lunar surface, this might create heat, which boosts the oxidation process and more rust forms. So, our planet does certain things that change the moon, but humans do the same. A probe that landed on the lunar surface back in 1959 was the first human-made object that touched the moon. That's also when we started altering the moon in unpredictable ways. Scientists call this the lunar Anthropocene. It's like an analogy with Earth's Anthropocene, a period when human activity made an impact on the planet. It's not like we can choose a certain starting point when such an activity began. But we now know that things we have done over the history of our existence have really changed the environment of our home planet. We don't have any people living on the moon yet, but we've already left some traces there. After humans first came to the moon, we've had many missions there. We left some landers and flags, moved lunar soil, brought golf balls, scientific equipment, and even some human waste. Plans for the future? Send more missions up there and even potentially create an infrastructure where some of us could live, study the moon's resources, and send them back to Earth. That's why it's important to talk about the lunar Anthropocene to remind ourselves we have to be responsible and take care of our heritage. Many people are confused about why we sometimes see the moon during the day. Some even believe it's something new that didn't happen before, especially after they started sharing a low-res picture of what looks like a full moon in the middle of the day. Some have pretty unusual ideas that the sun isn't the same color as it was before either. Allegedly, it used to be more yellow. The sun hasn't changed its color. It's still blue-green. But it's possible that we saw it as more yellow when we were younger because before, pollution wasn't as bad. And when it comes to the moon, we can see it both at night and during the day. It's brighter at night because there's no light coming from the sun. But it's not like it goes anywhere during the day. It's still there, but we just don't see it during the new moon phase. That lasts a couple of days, and during that period, the moon comes pretty close to the sun. The scattered light coming from the sun makes our satellite less visible to us. Speaking of the moon phases, they're easy to recognize when you know what to pay attention to. First, there's the black moon, which can mean a couple of things. One definition says that it occurs when we have 2 new moons in a month. Another one claims that the black moon happens when there's no new moon in a month, and that only happens in February. A blue moon is not called that because of the color. It's the 3rd full moon in a season that has 4 full moons. And a supermoon occurs when a full moon coincides with the moon's closest approach to Earth in its elliptical orbit. That's why it looks bigger than usual. Sometimes you can look up to the night sky and see an eerily red sphere up there. It's not about signs that tell us that the end of the world is coming or that werewolves are roaming around. But yep, blood moon is a good inspiration for stories like that. In reality, it's just an astronomical event when our planet casts a reddish shadow on the moon. And that happens when Earth comes between the moon and the sun, which is called a total lunar eclipse. Earth's little companion catches some red light coming from our atmosphere, and that's why you see that specific color. Soon we might start constructing loads of stuff on the moon. All because India's moon mission has recently detected sulfur near the moon's south pole. This chemical element can come in extremely handy for creating infrastructure on our satellite. It's the first time this chemical element has been discovered on Earth's natural satellite. This sought-after element is mostly found near Earth's volcanoes. Its appearance on the moon speaks volumes about the satellite's volcanic history and its past atmospheric conditions. The mission's rover detected this chemical element less than a week after touching down around 70 degrees from the moon's south pole on the 23rd of August, 2023. This historic landing on the lunar surface made India the fourth country to safely land a mission on the moon. It's also the first spacecraft to touch down so close to the south pole of our satellite. It's an area of strategic importance because it's believed to be home to deposits of water ice. If it turns out to be true, future missions might be able to harvest it and turn this water ice into drinking water or even rocket fuel. For 2 weeks, the lander carried out the data collection, mainly focused on the analysis of the moon's soil and its extremely thin atmosphere. Meanwhile, the solar-powered Pragyan rover started its quest to find frozen water on the moon. As for the lander, it demonstrated another amazing feat on the 3rd of September. The spacecraft fired up its engines and lifted itself for about 16 inches into the air. Then it made a tiny hop to land 12 to 16 inches away from its original position. It's kinda a big deal. Being able to get a lander back off the surface of the moon is essentially for future missions, showing that they can safely return soil samples or even astronauts back home after a lunar mission. In September, the Indian spacecraft was put into sleeping mode. The 14-day-long lunar night was approaching, and the spacecraft wasn't designed to collect scientific data during this period of time. So far, we've learned about a few major findings of the mission. One is related to measuring the temperature of the moon's topsoil at different depths. Intriguingly, the surface of the satellite in that region turned out to be hotter than expected. It was believed that the temperature could be between 68 and 86 degrees Fahrenheit on the surface, but it was around 158 degrees Fahrenheit, way hotter than it should be. The other discovery indicates the presence of several chemical elements, including oxygen. Besides, the data received from the spacecraft confirms the presence of aluminum, calcium, iron, titanium, silicon, and other chemical elements on the lunar surface close to the South Pole. The rover also used special instruments designed to measure quakes and rumbles beneath the lunar surface to detect some seismic activity. It brings us back to the sulfur detected thanks to the rover's spectroscope. Scientists are currently working on figuring out whether this element formed on the surface in a natural way or whether it's the result of volcanic activity or a meteor strike. Another astonishing thing found on the moon is a rock, and it may be the oldest known Earth rock. A 0.7-inch wide chip included in a large rock collection brought to our planet by Apollo astronauts might actually be a 4-billion-year-old fragment of Earth. This finding could help us paint a better picture of the intense pounding early Earth got at the dawn of its life. It could go like this. Soon after the rock formed, an asteroid impact might have blasted it from Earth. At that time, our planet's satellite was 3 times closer to Earth than it is today. The collision was so powerful that this chunk of terrestrial rock found its way to the moon. Later, this fragment got engulfed in a lunar breccia, a motley kind of rock. Eventually, the rock was brought back home to Earth by Apollo 14 astronauts. Even though scientists had found meteorites coming from Mars and the moon before, it was the first time a rock from the moon turned out to be a terrestrial meteorite. They also found out that the rock had formed in a water-rich environment at temperatures and pressures corresponding to those at around 12 miles beneath the surface of our planet. In 2019, China's Chang'e 4 mission made history by landing on the far side of the moon. The mission's rover helped researchers visualize structures hidden deep below the surface of the satellite, revealing billions of years of lunar history. The Yutu-2 rover made this discovery with the help of its lunar penetrating radar. It imaged deep into the moon's surface and listened to echoes of sound bouncing back off structures hidden from view under the surface of the moon. It turned out those structures were resting at depths of almost 1,000 feet. The research suggests that the first 130 feet under the surface are made up of layers of dust, soil, and rocks. The instruments also discovered a concealed crater that must have formed after a large object slammed into the moon's surface. Long, long ago, ancient lava was likely to be flowing deep underground. Researchers believe that the broken rocks around the formation might be debris produced by the impact. They also found that the volcanic rock layers were thinner the closer they were to the surface. Such a thickness variation of lava flows might mean a decrease in the number and magnitude of eruptions over time. So, lunar volcanic activity gradually dwindled since the moon's formation around 4.5 billion years ago. On the far side of the moon, there is one of the largest and oldest impact craters in our solar system, the South Pole Aitken Basin. Unfortunately, from Earth, you can only see its outer rim, which looks like a huge chain of mountains. It's a ginormous 8-mile deep dent, stretching for more than 1,500 miles in diameter and covering 1/4 of the moon's surface. Astronomers are sure that this crater appeared when an asteroid collided with the moon around 4 billion years ago. And now, look at this gigantic chunk of metal the size of 4 states of Connecticut. As for its weight in pounds, it's enough to say that the number contains 18 zeros. This mysterious mass is hidden about 180 miles under the moon's surface, somewhere in the middle of the South Pole Aitken Basin. It was discovered when GRAIL, which stands for NASA's Gravity Recovery and Interior Laboratory Mission, gathered data about our natural satellite. When examining this information, scientists noticed that in one place on the moon's surface, there was a weird change in gravity. After researching this phenomenon, they concluded that something mysterious was weighing down the basin floor there. So far, researchers haven't figured out the origin of the bizarre lump, but there are several theories. One of them claims that the finding is a chunk of dense oxide, which appeared when the moon was just taking its shape. At that time, the satellite was still covered with ancient oceans of magma, and the lump could be formed at the final stages of its cooling. However, most scientists support another theory, according to which the puzzling mass is part of the giant asteroid that once created the South Pole Aitken Basin. Since the thing is metallic, it's probably the iron-nickel core of the asteroid. There might be a labyrinth of lava tubes on the moon. Not so long ago, astronomers received the results of underground topography and discovered a massive cave under the surface of Earth's satellite. It could be the result of the lunar volcanic activity that happened more than 3 billion years ago. Streams of lava hardened, creating a thick, hard crust on the outside. But inside, it kept flowing, melting the rock and creating tunnels and caves. Numerous small pits in the moon's surface discovered by NASA seem to be the openings to such lava tubes. If this theory is confirmed, the underground tunnels might serve not only as a convenient location for human-crewed space missions, but also as much-needed water sources for astronauts.
Pluto used to be considered a major planet, but later was reclassified into something called a dwarf planet. Something too big to be an asteroid, but too small to be taken seriously. How rude. But recently, scientists began to discuss the mystery surrounding one of Pluto's moons. It turns out it might be even cooler than all of us. It might be a double planet system. Pluto is residing in the distant Kuiper Belt. It's a vast area in our solar system, like a big rocky suburb beyond the orbit of Neptune. It's filled with small icy objects, similar to Pluto, called Kuiper objects. They're leftovers from the early days of our solar system and give us clues about how it was formed. It's where many comets come from. You already know that it's small, but it's remarkable just how small it is. Pluto has a width of about 1,400 miles. It's about half the size of the United States and smaller than our moon. Pluto's atmosphere is very thin and composed of nitrogen, methane, and carbon monoxide. Stinky. It's also very cold there, with average temperatures being around minus 390 degrees Fahrenheit. Its orbit around the Sun looks like an oval, and 1 year on Pluto takes around 250 Earth years. Pluto also shows a strange and unusual retrograde rotation because it's tilted on its axis, which means that it spins on its side. If you were standing on Pluto, you'd see a lot of high, icy mountains, valleys, plains, and craters. The Sun would be very dim and far away, and it would always look like twilight. It's a colorful planet, surprisingly. You would see a rainbow of pale blues, yellows, oranges, and deep reds. And the most adorable fact about Pluto is its famous heart, called Tombaugh Regio. Pluto was discovered super late in the 1930s, later than the rest of the planets. Initially, we thought that it's the 9th planet in our solar system. However, the more we explored the Kuiper Belt, the more we realized that it's full of these medium-sized objects. We found 4 more little planets just like Pluto: Eris, Ceres, Makemake, and Haumea. They all shared the same characteristics, and that's where we figured out that Pluto belongs to another family and created a category of dwarf planets. There are a couple of differences between these two categories. The first obvious difference is size and mass. Major planets are much bigger and more massive. They also have to be spherical, while dwarf planets might not be perfect spheres and might have weird shapes, like an egg-shaped Haumea, for example. And just like a regular planet, a dwarf planet orbits the Sun, but it doesn't have a clear orbit. Its orbit is full of debris and random objects. These are the only differences between the two. Well, as you can imagine, the reclassification sparked quite a controversy. People even made up a new term, Plutoed, which means downgraded. But although it might be sad that Pluto isn't a major planet anymore, we can look at it like a story about finding your true family. And finally, while standing on Pluto, you would see its 5 moons: Styx, Nix, Kerberos, Hydra, and the most mysterious one, Chiron, also pronounced Charon. So you can pronounce it however you like. I'm going to go with Charon. Now Charon is Pluto's largest moon. It was discovered in the 70s thanks to NASA's spacecraft called New Horizons. The spacecraft took a picture that revealed a moon with a strange and fascinating huge red-brown spot on its surface. It's a vast canyon dwarfing the Grand Canyon. It seems that both Pluto and its moon can boast interesting formations on their surface. The thing about Charon is that it's very big for a moon. It's about half the size of Pluto. This makes scientists wonder, could it be that Pluto is a double planet system? The center of mass, or barycenter, of Pluto and Charon lie outside of Pluto. Normally, with planets and their moons, the center of the planet itself should be the center of the mass, with the moon orbiting around it. But in the case of these two, it seems like they orbit each other. Binary objects are quite common in the universe. These cosmic pairs form just like our moon, from giant impact events. But double planets are exceedingly rare, and we haven't discovered any double dwarf planets yet. So, if it's true, then Charon is actually the 6th dwarf planet, and that would be our first binary dwarf planet system ever. There's also another candidate, the dwarf planet Eris and its moon Dysnomia. The solar system is full of mysterious and fascinating moons, so fascinating that some of them might not even have actual life on them. We've been talking about microscopic life in space for a while now. The debates about whether we found some organic fossils on Mars or not have been going on for decades. With the development of our technology, we're finally getting onto something. Meet Enceladus, who has stolen the spotlight since NASA's Cassini probe arrived there. Enceladus is covered in a sort of snowy blanket, which is why it's so unusually bright and has some snow-covered craters. It's small, only about 310 miles, and is mostly composed of simple rock and ice. But in 2004, we found plumes of water bursting out from this moon's south pole, which means that there's liquid water beneath this moon's icy surface. It's probably because of Saturn and its other larger moon, Dione. Their gravitational dance creates tidal forces that keeps Enceladus warm and lively. All this means that Enceladus is now a top candidate in the search for life within our solar system. Of course, life requires more than just water. And we won't find any animals there or anything like that. But we might find some microscopic organisms, and that's awesome too. In fact, Saturn is winning the lottery when it comes to life candidates. For example, scientists have a wild idea that Titan, another of its moons, might be home to extraterrestrial life as well. Titan is a frosty moon, chilling at about minus 290 degrees Fahrenheit. Surprisingly, it has some lakes on its surface. But don't imagine your typical water bodies. These lakes are believed to be filled not with water, but with liquid ethane or methane. Back in 2005, NASA discussed that there might be life munching on chemicals like acetylene or hydrogen in Titan's lakes. And then, in 2010, NASA investigated this moon some more. They found missing hydrogen and acetylene on Titan's surface, hinting at the possibility of something eating away at these substances. That's why some scientists dare to imagine methane-eating beings in Titan's freezing lakes. Moreover, they suggested that if these creatures exist, they probably have much larger cells than animals on Earth. What we could find there is something much bigger than a simple microbe, even something like a small animal. But Saturn isn't the only lucky one. Triton is Neptune's biggest moon. And you guessed it, it's another life candidate. It's an icy world with frozen nitrogen all over its surface and a crust made of water ice, again super chilly. However, Triton is a hotspot for geologists because it's one of just 5 moons in our solar system that likes to show off with its active geysers. It's shooting nitrogen gas up into space. That would be a cool show, if we could see that. These geysers mean that Triton has some secret source of warmth, which means that, just like with Enceladus, there might be some liquid water underground on Triton. And if this cozy spot for life does exist, we might find some organics there. Unfortunately, sending a mission to explore these celestial bodies isn't easy. The only spacecraft we've sent so far was our Voyager 2 in 1989. We need more time, money, and technology to develop spacecrafts that would be able to travel far and investigate the area beyond Mars. And even if we do, it'll take decades for this spacecraft to reach these places. In any case, let's hope that during the 21st century, we'll finally be able to fully explore our solar system and all its mysteries. August 23, 2023, a day when India's Chandrayaan-3 spacecraft made history by becoming the first to touch down on the lunar South Pole, a place we can't normally see from Earth. What makes this lunar hideaway so fascinating to scientists? Well, it turns out it's hiding something precious: lunar ice. This place is believed to be more abundant with this ice than what we found up north. And it's not hard to see why scientists are so buzzed up about it. It's a frozen water source, and it could become our key to building a permanent lunar home, or even fueling missions all the way to Mars. Scientists knew about this ice for over 2 decades, since the NASA spacecraft accidentally stumbled upon it during one of the missions. Then in 2018, NASA triumphantly declared that they're 100% sure about it. They said that the south pole of the moon is abundant with water. Now, picture this. Future lunar settlers could tap into this water supply. It could help us sustain life in the barren lunar landscape. Plus, by cleverly splitting the water into oxygen and hydrogen, we could receive both air and rocket fuel. All this will make moon missions more feasible and self-sustaining. It's also a great glimpse into the past. This ice, maybe as old as the moon itself, could unlock the moon's and Earth's deep mysteries. But it turns out that water isn't rare in space at all. There might be lots of planets out there where life could thrive. We know this because we started finding water vapor around stars, and this water is remarkably similar to the water in our own solar system. This discovery suggests that the water on Earth originally came from space. Water forms around stars in the cloud of extremely hot vapor. Then it turns into ice and sticks to tiny dust particles. These particles stick together over time and become bigger objects, like comets, planets, and other things. Some of these become comets and planets in our own solar system. And this is how water is being spread across the universe, and it may be how it got to our planet and the moon too. Scientists think that the lunar ice might have journeyed here eons ago. Maybe it hitched a ride on water-rich asteroids that smacked into the moon's surface. All this has big implications for us. The southern pole is an ideal canvas for humanity to establish a real moon base. Imagine brick domes connected by secret underground tunnels. They'll be bustling with people busily operating computers. Some others will be cruising the lunar landscape in their jeeps or on their way to mine precious resources. We have some pretty cool ideas on how to build this. First, you probably imagine hauling hefty and water-draining shelters all the way from Earth. But maybe there's a more effective way. Think about our history as a civilization. Every time we ventured to a new place, we surveyed the surroundings for available resources and used them to survive and thrive. This is how we spread across our own planet. So why shouldn't we spread across the moon the same way? Now, you might wonder what resources the moon might offer. We know about the ice, and it can be turned into water. But we can clearly see that our planet lacks lush greenery and edible food. Well, it might not be obvious, but the moon does have something to offer: mineral resources and sunlight. Unlike Earth, where the sun rises and sets, the lunar poles offer quite a beautiful sight. The sun gracefully orbits the horizon the entire day, which means it can provide an almost uninterrupted source of power. Imagine living in a world bathed in perpetual sunlight. I'm sure the solar panels will love it. Me? Not so much. Still, we could use not only the sun's light, but also its heat. Honestly, we should just use everything. If we're left with spare metal while producing oxygen, find a purpose for that metal too. We need to treat the environment responsibly, not only on Earth, but on the moon as well. Which is why scientists are learning how to turn the moon's most abundant resources, regolith, into sturdy bricks. They've been quite inventive in figuring out how to create moon bricks. Scientists want to use the sun's heat to melt lunar dust, layer by layer, essentially creating a 3D printer for moon dust. Engineers have also cooked up bricks using solar ovens and zapped lunar soil with microwaves. They become quite adept at it. So yeah, perhaps we're going to establish a little brick factory on the moon and build regolith houses. It's like Minecraft in real life. As soon as you find some cool new material, you gotta build a tiny house with it. If successful, these bricks could be used to construct entire buildings, potentially covering inflatable modules or giving new life to abandoned landers. So, will astronauts need to become skilled bricklayers? Well, they won't do everything themselves. We'd have to create a small automated system involving robots working collaboratively. Humans will, of course, oversee the construction site. Despite all this automation, scientists believe that living on the moon is going to be, well, call it cozy. The designs may involve stacked living quarters or multi-purpose areas. However, there would be some challenges too. On the moon, things get extreme. Imagine scorching temperatures that can go up to 212 degrees Fahrenheit during the day, and at night, they plunge down to a chilly minus 290 degrees. And it's not just the weather. The moon gets relentlessly exposed to solar radiation, cosmic rays, and micrometeorite impacts. All these things gradually wear down anything on its surface. Another big challenge is the lunar dust. On the moon, there's no air to breathe, and the dust there can cause problems. And this one isn't only regular dust. It's super clingy and can even make astronauts sneeze and have watery eyes, as if they're having a lunar hay fever. It can also damage equipment and spacesuits. It's not something you want to mess with. Scientists have found that the dust is made when meteors hit the moon, creating tiny particles and sharp glass shards. It's toxic, and its tiny particles can float around in low lunar gravity, making it hard to breathe. Unlike on Earth, the moon doesn't have wind or rain to clean it away. So now they're studying it to find out how to prevent this annoying problem from ruining their entire mission. There's more to this lunar haven than meets the eye. Scientists also want to delve into the mysteries of low-frequency electromagnetic waves there. These waves are whispers from the far reaches of the universe. These elusive signals have remained hidden from us for ages. We only caught some cacophony of radio and other background noise, but that's it. On the moon's dark side, however, we can finally record and study them. Studying these waves will help scientists to unlock the secrets of the universe's origins. It's not just about the Earth or the Moon. We're talking about peering back to the very beginnings of our world. Our new lunar lab might help us to forever reshape our understanding of the cosmos. So, NASA has some big plans on the Moon now. Their Artemis mission completed a successful return to Earth in December 2022 after nearly a month in space. It ventured far beyond the Moon. This mission proved the capabilities of some of our recent technological developments that will help us explore Mars. The goal of Artemis is to establish a lasting presence on the Moon. They want to create a gateway, like a space station in orbit around the satellite, to help with the landings. Artemis 2 is set to carry astronauts to lunar orbit in 2024, and during Artemis 3, which should take place in the mid-2020s, 2 astronauts will touch down near the Moon's south pole. It's quite possible that the lunar base will be built within the next couple of decades. So, stay tuned.
Our moon exploration project started out in 1969. Sure, there have been some problems along the way, but astronomers are certain we'll get back up there pretty soon and with better knowledge and technology. However, there's an 800-year-old trick that might become way more useful than fancy GPS tech and powerful rockets. It's called the Fibonacci sphere. Some scientists at a Hungarian university stumbled upon this idea while studying the moon. They believe it might be useful to better understand how the moon spins and how it's a bit squished while it goes around Earth. You might believe that our planet and its satellite are these perfect little spheres floating in space. Well, that's not true. They are in fact like slightly deflated soccer balls because of all the gravity, rotating movements, and tides. The GPS technology we use here on Earth is already adapted to these less than perfect ball proportions. Remember, our planet is a bit flattened at its poles. If we're going to make a map system for the moon, we need to do the same for its shape, called a solenoid, or what scientists call the moon's version of our Earth's shape. Since the moon is less compressed than our planet, scientists have been taking a shortcut until now. They've been looking at our satellite as a simple ball shape. However, with all these new projects coming up in the following decades and even some exciting trips we might end up having on the moon, we need to be more precise. Scientists now believe we should get the real data and start drawing an accurate picture of the moon. Here's where the Fibonacci sphere comes in handy. It's a clever solution that's been used by mathematicians to spread points out evenly on a ball. Scientists recently used it to map around 100,000 spots on the moon using data previously collected by NASA. And what they found was crucial for our understanding of the moon's shape. For instance, we now know that our satellite's poles are about 0.3 miles closer to the center compared to the moon's equator. Sure, it might seem like a tiny detail, but if we adjust our GPS software accordingly before we land on the moon again, it might save us from getting lost up there. This level of math hasn't been done since the 60s for the moon, but we already know it works wonders here at home, so it only makes scientists better prepared for future missions. This isn't the first time people have used Fibonacci's findings to come up with clever solutions. We've also seen it put to work in finance, agriculture, and in computer science. Let's see where it all came from. Legend has it that the Italian mathematician Fibonacci wasn't really that interested in mathematical sequences at first, but rather in rabbits? So, he came up with this interesting puzzle. What happens if you place a pair of rabbits in a certain space for a year? He also set some theoretical rules. For starters, all those bunnies come in boy-girl pairs, and they can start reproducing after just a month. Each month, each bunny pair adds one more pair of bunny offspring. The last rule was that all bunnies would be invincible for the year. Doing the math, he got this series of numbers. 1, 1, 2, 3, 5, 8, and so on. If you look at this series again, you'll notice that every number is the sum of the two before it. The first two, that's your starting bunny pair. Next, you'll see the number 2, which is the first pair and their first offspring pair. Word caught on about this interesting sequence, and math lovers began studying it more closely. They started seeing this pattern very often in nature, like in how leaves grow on a plant or how seeds arrange on sunflowers. There's even a little experiment you can do to check it out. Start by grabbing some paper and a pen. Try drawing the Fibonacci spiral. Start with a tiny circle, then go bigger and bigger using those Fibonacci numbers. The first circle should just be a tiny dot on the paper, or the equivalent of 0. Next circle, 1 unit. Another circle, still 1 unit. Keep it going and you'll see that the circles form this spiral pattern. Even as it continues to grow, it keeps its shape. You might have also stumbled upon the Fibonacci spiral as a symbol of hypnosis. In all fairness, there's little evidence you can confuse someone by making them stare into a spiral for a while. But its effects on our focus and our optic nerves can't be ignored. After you've stared at a spinning spiral, you might see how objects get smaller or bigger depending on the direction of the swirl. It's easy to understand why some experience this sensation as hypnotizing. This interesting series of numbers appears in our day-to-day lives, even if we don't notice it. It can also be used in more practical instances, like converting miles to kilometers. Let's look at the series 1, 2, 3, 5, 8, 13. Pick any two numbers side by side. Say 13 and 21. Do the calculations and you'll notice that 13 miles is about 21 kilometers. Same with 34 and 55. Music and math might not seem like they're connected. But if you had asked the great Mozart, he probably wouldn't have agreed. It seems he was very passionate about numbers from early on in his career. He loved finding cool number patterns in music, like some sort of hidden messages. His own sister even remembered him doodling math all the time, even on the sides of his music sheets. Some scholars believe he might have even played around with the Fibonacci numbers. If that's really the case, then he might have used the ration to balance out parts of his tunes. What about other types of art? Well, it's also said that Leonardo da Vinci used the golden ratio in his masterpieces, like the Vitruvian Man and the Mona Lisa. Also, when it comes to great pieces of architecture, the Parthenon might have used this pattern too. Anytime you see buildings with columns spaced just right, you can be certain that's where the builders drew inspiration from. The Great Pyramid of Giza is another great example. There's no official record to prove it, but the pyramid's shape is so close to the golden ratio that it's kind of obvious. You'll also see this pattern appearing naturally in our environment. Go out in our garden and check to see if you have any pine cones lying around. See those scales? They're set up in a pattern according to the Fibonacci sphere. Even the bones in our body seem to be growing based on the same proportions. We've got one torso, one head, and one heart. Then there's stuff that comes in pairs. Our arms, legs, eyes, and ears, for instance. For the number 3, think about the composition of our limbs and the 3 main sections in our hand. The wrist part, the middle palm part, and our fingers, which are also split into 3, by the way. Oh, speaking of fingers, their bone lengths have this ratio too. This design helps our fingers move smoothly, especially when grabbing objects. The Fibonacci sequence can be seen in the way ocean waves curve, and how rivers split and flow too. Weather patterns can also follow this rule. Some whirlpools and hurricanes form and spread out in the same way the Fibonacci spiral does. Zoom out, and you'll see that spirals aren't just found here on Earth. They're also everywhere in space, and it isn't random. Most galaxies, including our Milky Way, are spirals. Think of it like this. Generally, stars in a young galaxy don't all appear at once. Some are faster when developing, others take their time. This makes gravity pull in different ways, making the young galaxy spin like a disk. As it spins, different levels of gravity stretch it into getting these spiral arms. On the flip side, if all the stars in a young galaxy appear at the same time, Gravity just smushes it all into an egg shape, or what the astronomers call elliptical.
It's been decades since the last manned moon landing, Apollo 17, which happened in December 1972. Isn't it time we thought about going back to our dusty satellite, and maybe even staying there? NASA has made a promise on this subject. They're preparing to send astronauts on the moon again, perhaps by 2025. This will all happen through a program called Artemis. It's also going to include the first woman ever to experience the lunar surface. Now you might ask, why haven't we done this already? One former NASA administrator said something interesting on the subject. It's not because of scientific or technological issues. Problem was that the potential projects took too long and were just too costly. You see, space travel, especially when it involves humans, isn't easy on the pockets. It's true that, in recent years, NASA had budgets of billions of dollars. Sure sounds like enough money, right? Well, not when you check out their to-do list. That's because they have to consider everything. From telescopes and giant rocket projects to missions also targeting the Sun, Jupiter, Mars, and beyond. When you look at it this way, NASA needs to be very good at budgeting to achieve all those goals. It's not just because of finances, though. The moon itself is quite problematic. It poses real dangers that cannot be taken lightly. For starters, its surface is filled with craters and boulders that aren't easy to land on. Then, there is the moon dust, or regolith, if you'd like to call it by its scientific name. It was created over many years by meteorite impacts. It's extremely harsh and sticks to everything. It can potentially damage spacesuits, vehicles, and systems quite quickly. Also, dealing with the lunar habitat isn't a walk in the park either. The moon has no protective atmosphere. What this means is that for 14 days at a time, the lunar surface is faced with harsh rays from the sun. That period is followed by another 2 weeks of total darkness. All these changes create extreme temperatures, which us humans are not really accustomed to. There are solutions, don't worry. NASA is working on dust and sun-resistant spacesuits and vehicles. They're even developing a system that might supply electricity during those lunar nights. What's even more interesting about this system is it could come in handy on Mars too, once we get there. NASA also needs to draw in really smart people for its projects. Think about it. The average age of the people working for the mission control for Apollo 13 was just 26 years old. And these people had already been part of numerous missions by that time, which means they'd had considerable experience from a very young age. But here's where other individuals can help too. In recent years, it wasn't just NASA who's been working tirelessly to revolutionize space travel. There are many successful people out there with enough resources to join in on these efforts. Some are developing new types of rockets that can land on the moon too. In total, NASA landed 12 people on our satellite. It's definitely one of the most awesome moments in its history, if not the best. And those astronauts did amazing things up there. They brought back rocks, took snapshots, did science experiments, and even left flags behind. These were all important moments of the Apollo missions. But they weren't meant to create a safe place for humans on the moon. Scientists have had this idea of a lunar space station for a long time now. It's only logical. After all, it's just a 3-day trip from Earth. It means we can, technically, afford to make little mistakes here and there, without messing up the whole project. Plus, we'd learn so much before venturing even further into space. A moon base could provide fuel for deep space missions. We could also build telescopes up there and launch them way easier in space. It could also help us in another important project. Figure out how to make Mars habitable too. Not to mention, a lunar space station would help us learn more about the moon's origin. Who knows, it could even bring in some money because of all that fun, exciting lunar tourism. Either way, the Apollo moon program took a lot of work. For starters, let's look at the sheer number of people involved. Around 400,000 from every corner of the states. Not everything was picture perfect, tough. There were two main unfortunate events. Firstly, a fire mishap at the launch pad of Apollo 1. Secondly, an oxygen tank decided to throw a tantrum on Apollo 13, causing severe issues mid-mission. An important part of the project was Saturn V. It is to this day the most powerful rocket flown successfully, being 36 stories high. Still finding it hard to picture? This rocket stood twice as tall as Niagara Falls. Thanks to Saturn V, NASA successfully completed 13 missions. This included chauffeuring 24 astronauts towards the moon, with half of them even having a little walk on its surface. The existing rockets and space shuttles can't go beyond low Earth orbit. In simpler terms, they can't reach the moon with all the gadgets astronauts need to thrive. Current space vehicles are just not capable of carrying that load, at least not since the Apollo missions happened. Regardless, we did make a lot of progress on Earth and are ready to send astronauts to our satellite pretty soon. Here's where the Artemis project comes in. It's a program overseen by NASA. And to make sure it all goes well, NASA previously launched Orion, a spacecraft with no crew on board to orbit the moon and return to Earth. Think of it as an automated test drive. Before we actually send people out there again, we need to make sure all the devices work properly. One day, Orion will be the vehicle that will take astronauts to the moon again. It features a launch abort system to keep astronauts safe in case something bad happens during launch. It also has a service module, which is the powerhouse that fuels and propels Orion and keeps astronauts alive with water, oxygen, power, and temperature control. All these future projects make one wonder, what will life on the moon be like anyway? We can only use our imagination for now. Some say we'll be living in homes straight out of a fairy tale, something like a cozy hobbit hole. Living underground on the moon might be a must. That's due to the scorching temperatures and the lack of oxygen. If you add meteorite threats and the non-stop radiation, it's no wonder we can't just walk on its surface. What about transportation? Big and small companies alike are trying to create the ideal moon ride. If current estimations are current, one type of moon taxi will take off as soon as 2024. Unlike our current rockets, these space taxis won't have to deal with the harsh conditions of re-entering Earth's atmosphere. It will be easier for them to make multiple round trips. To support our lunar living, we'll need to have a special area for space taxis to safely take off and land. Think of it as a landing pad on a firm, flat stretch of moon surface, protected by walls to shield against moon dust. Moving around on the moon's surface will be made easier too. The next generation vehicles we're talking about will have their own controlled environment, which means you won't need a spacesuit while inside. Should feel like stepping out of your space ride for a bit. Then of course, you'll need to put on your spacesuit. All right. So we've got our homes and our rides sorted. But what about fuel? That's where the moon throws us a lifeline. The moon's lighter gravity means we don't need as much power to escape its pull. Plus, the moon has ice, and that's super handy. We might be able to convert this ice into rocket fuel. We'll need dedicated space gadgets to help gather this ice. One such tool is called Trident. It's like a drill, perfect for digging into the icy moon surface. Additional robotic helpers would then turn this ice into fuel and deliver it to a space gas station. If this works, rockets on their way to Mars could stop by for a quick fuel top-up before continuing their journey.
It's one small step for man, one giant leap for mankind.
Is one of the most famous quotes of all time. But was it really what Neil Armstrong uttered on July 20th, 1969, as he set foot on the moon for the first time in human history? It looks like it both is and is not. Thousands of people back on Earth who were following the historical event heard the phrase without one small detail, the indefinite article, A.
It's one small step for man, step for man.
There's no such thing as small details when it comes to grammar, and the absence of A slightly changed the meaning of the whole sentence, since man and mankind became synonyms in that case. It basically meant, that's one small step for mankind, one giant leap for mankind. Neil Armstrong himself told the press after the Apollo 11 mission that there definitely was an A there, but people just didn't hear it. 30 years later, at the event's anniversary, Armstrong couldn't hear the article while listening to the recording of that famous transmission.
It's one small step for man.
He explained that he wasn't the most articulate person, and he left a lot of syllables out. So it could have been a suppressed sound, and the voice mic simply failed to pick it up. But he insisted that A had been intended, as without it, the statement wouldn't have made sense. In 2006, a computer programmer backed up Armstrong's words with some digital magic.
It's one small step for man.
He ran the audio through some software that singles out nerve impulses and saw it in the graphic form of sound waves. It became obvious that there was a 35 millisecond long bump of sound between 4 and man. It was too brief for other humans to hear, but Neil clearly did leave room for an A. Several years later, Ohio State University studied the speaking patterns of Central Ohioans, like the first man on the moon, and noticed that they often leave out words like for and A. In a BBC documentary, Armstrong's younger brother Dean mentioned that he had seen the quote written on a piece of paper months before the mission. Whether it really happened or not remains a mystery because he had never mentioned it before the documentary. Like with many famous quotes, people tried to find some symbolism behind Armstrong's words. One of his biographers suggested that the quote was inspired by the astronaut's love for J.R.R. Tolkien's books. There was a similar line in The Hobbit. Not a great leap for a man, but a leap in the dark. He found that connection because Armstrong had a Tolkien-themed email address in the 90s, and after retiring from NASA, moved with his family to a farm dubbed Rivendell. It was also the name of a valley and the home of Elrond, the half-human, half-elf from Lord of the Rings. Armstrong himself denied that connection since he hadn't read any of Tolkien's books before going on the Apollo 11 mission to the moon. Others believe the quote was based on the NASA memo. Going to the moon was no walk in the park, so it was important that the first person there pronounces some iconic words about it being a historic step forward for all mankind. Again, the astronaut denied having any memo. He later shared that it had just been the most logical and right thing to say. Armstrong literally had to go a long way to make that legendary step. He took his first airplane ride at the age of 6 in a Ford tri-motor plane with his father, and that's when he fell in love with aviation. He was an active Boy Scout and earned the highest possible rank, Eagle Scout. On his 16th birthday, he became a licensed student pilot before he got his driver's license. He then went on to study aeronautical engineering. His program involved 2 years of university studies at Purdue University, then leave for 2 years of flight training and 1 year of aviator service before returning to finish his final 2 years. While at Purdue, Armstrong joined a fraternity and wrote and directed a musical for the school varsity varieties. He was investing so much effort in his version of Snow White and the Seven Dwarfs that he got a C that term in psychology for engineers, a C in aircraft vibrations, and a D in electrical engineering. During his aviator service, Armstrong had to eject from the plane over the water. The winds were taking his parachute back to land. When he thought that was it, his friend from flight school in a service vehicle picked him up and saved his life. Armstrong came back to Purdue, completed his degree, got married for the first time, and became a civilian research pilot right after. The couple moved to California, and whenever he flew over their house, Neil would tip the wings for his wife and son on the ground to see it was him. He had over 1,100 flight hours testing various supersonic planes and the X-15 rocket plane. He wasn't able to apply when the U.S. Air Force was recruiting for the first Man in Space Soonest program in 1958 because they didn't accept civilian test pilots. In April 1962, NASA accepted applicants again for Project Gemini, and this time he was eligible. Neil handed in his application past the deadline, so it was only thanks to a flight simulator who had known him and slipped the application in the pile that he got into the space program. Back then, he wasn't considered NASA's #1 pilot and flew as a backup crew. In 1966, Armstrong became the first American civilian in space, and together with David Scott, pulled off the first manual space docking maneuver. And that's where things have gone wrong. After docking, a rocket thruster had a meltdown and the spacecraft started spinning uncontrollably. They had to separate from the Agena. Armstrong took back control of the Gemini spacecraft, and they managed to perform an epic emergency splashdown in the Pacific Ocean. Then, it was time to choose who was going to become the first human on the moon. It had to be a civilian, and the decision-makers at NASA chose Armstrong for that honor. Some people believed it was because he had a likable personality, quiet confidence, and was working hard on the way to the stars, literally. To prepare the astronauts for landing the lunar module and the reduced gravity they'd experience, NASA ordered practice vehicles to be built. In early May 1968, at just 98 feet above the ground, Armstrong's vehicle started rolling without control. He had to act quickly and eject to save himself. Later analysis proved that if he had done it just half a second later, that would have been his final moments. On July 16, 1969, Armstrong, along with other members of the mission, took off for the moon. NASA built the Saturn V, the most powerful rocket that had ever flown successfully, to take them there. It was as tall as a 36-story building. 4 days later, they reached their goal. After spending 21 hours and 36 minutes there, leaving their footprints, which are still visible on the moon's surface, collecting surface samples, taking photos, and testing scientific instruments, and headed back to Earth. Armstrong didn't enjoy public attention that much, so he decided to take up a teaching career. He became famous worldwide, but he still had to work hard to defend his master's thesis at the University of Southern California. He then retired from NASA and moved back to Ohio with his family, where he would teach for the following 8 years. He didn't cut the connections with NASA altogether and worked with them on several commissions, helping the investigations into both the Apollo 13 malfunction and the tragic Challenger space shuttle incident. In 1985, Armstrong journeyed to the North Pole with a group of fellow explorers. It made perfect sense that he wanted to see it not only from space, but from the ground level. For his giant leap for mankind, Armstrong was awarded the Presidential Medal of Freedom, the Congressional Space Medal of Honor, and the Congressional Gold Medal.
How about playing golf? Not on Earth, but on the moon. Let's journey back to a time 50 years ago when one astronaut turned the lunar surface into the most unusual golf course ever. Any golfer will tell you how tricky it is to avoid sand traps, but picture Alan Shepard, a NASA astronaut dealing with an entire surface that feels like super fine powder. During the Apollo 14 mission, he took a break to showcase some spacey golf skills for everyone watching from Earth. After his first shot, he excitedly made another. For him, it seemed the ball went forever and ever. Let's dial back to reality for a moment. Thanks to the research by the United States Golf Association, or USGA, we've got some numbers. They found that Allen's first moon ball traveled 24 yards, and his second stretched for 40 yards. Now, how does that compare to the average golf shots back here? In regular gravity, one usually swings to about 216 yards. Just goes to show, while we've upgraded our golf game on Earth with tech and training, the moon's low-gravity playground is a different environment altogether. Now let's give Allen some props. Moon golf? Not as simple as you might think. His club wasn't one from your local sports store, it was a makeshift one. A moon sample collector with a club head stuck to it. Add to that the bulky spacesuit he had on. Imagine trying to swing wearing an outfit that's as stiff as cardboard. With all that gear, Allen could only muster a one-handed swing. Care to have a similar experience? Well, you might not be able to play golf on the moon anytime soon, but you can give it a shot underwater. Some say the conditions are similar. Here's where it gets even more interesting. The USGA didn't just take Allen's word on where the balls landed. They wanted to investigate. For starters, they used ultra-clear footage of the Apollo 14 mission. They also used some sharp images from NASA's special moon camera, launched in 2009. Using this imagery, they mapped out the journey of those two golf balls. Allen loved his unique golf club so much, he wanted to bring it back home. No big deal, right? Well, you see, in those days, astronauts would leave behind unnecessary items to make space for moon rocks. But not this club. So during the 70s, this interstellar golf club found a new home at the USGA Museum in New Jersey. Unlike regular golf clubs, this one had a twist. It was crafted from aluminum and Teflon. It was built to fold and fit snugly within the tight spaces of the lunar lander. How did this whole moon golf idea even pop up? Well, in 1970, golf legend Bob Hope paid a visit to NASA. Inspired by Hope's love for golf, an idea came into Shepard's head: moon golf. To turn his dream into reality, he collaborated with a golf professional and NASA's tech specialists. Together, they crafted a club that met NASA's strict safety norms. But hey, Allen didn't want this to be just a surprise stunt. Remember, traveling to the moon required very strict protocols. They couldn't just randomly have a picnic up there, you know? So, Allen made sure NASA officials agreed with this impromptu game of golf. They were initially skeptical, but eventually gave the green light after Allen passionately laid out his plan. He also promised he'd start playing if everything went smoothly on the mission. Determined to make it perfect, Allen prepped like a champ. The story goes that he'd put on his hefty spacesuit and sneak off to secret spots so he could practice. Decades later, he'd still be reflecting on his lunar escapade. He was the only golfer to ever swing on the moon. It's not just golf balls that astronauts left behind on their trips. There were actually a lot of objects left on the moon between 1969 and 1972, the year of the last moon landing. Each time you gaze up at the moon, remember that there's a cute family photo up there, some huge science gadgets, a small statue, a bunch of, well, human waste bags, and yes, some American flags. Years have passed by, and yes, technically those items are still hanging out there, though they've probably seen better days because of the harsh conditions on the moon. Some items had a special place in the astronauts' hearts and were meant to stay on the moon. But hey, leaving some stuff behind also meant they could bring back moon samples. You know the feeling. It's like when you need to make room in your suitcase for souvenirs when you're finishing a vacation. Does NASA have a complete list of things they left on the moon? Well, not really. In fact, one team tried to create a record of some of the items and reached an amazing list of 106 left there from the Apollo 11 mission alone. And that's not counting Neil Armstrong and Buzz Aldrin's famous footprints. The largest items at each landing site were mostly the sciencey stuff, like pieces of their lunar module and experiments to study the moon in depth. Then there were some beautiful tokens, like Apollo 11's plaque and a special disc with messages from leaders around the world. Some say the astronauts also took medals to remember some heroic cosmonauts, and they even left a gold olive branch, an age-old symbol of peace. Now, later moon missions had a little more fun, like Alan Shepard did with his golf game. But the award for the most heartwarming moment goes to Charlie Duke. During the Apollo 16 mission, he left a picture of his family up there. It's like he wanted them to be a part of the adventure. Although, a heads up, those photos probably didn't age well because of the moon's high exposure to the sun's radiation. There might just be an art museum up there on our satellite too. Let me explain. There's this tiny little art piece called the Moon Museum. It's a ceramic chip about the size of your nail, and it was crafted by an artist named Forrest Myers. This tiny object showcases miniature artworks from 6 talented people. Among them are even the famous Andy Warhol, the same artist known for his iconic soup cans and celebrity portraits. Forrest Myers said he wanted his mini museum to be on the moon, but there was a problem. NASA officials weren't exactly on board with the idea. However, Myers shared with the press that he handed over this art chip to an engineer working on the Apollo 12 mission. According to Myers, this engineer secretly tucked the Moon Museum onto a leg of the lunar lander. In case you haven't figured it out yet, these lunar landers don't come back to Earth after their mission. Take this with a grain of salt though, as NASA has never confirmed this story. You might wonder, why did they leave all these things? Sometimes it was about making a statement. Other times, it was purely practical. At one point, it was mentioned that during the Apollo 11 mission, for example, a decision needed to be made. The astronauts had to quickly figure out what was essential for their trip back home. They ended up creating a cleanup spot, tossing away things they didn't need anymore. Leaving things behind on the moon isn't that different from how we leave things behind on Earth, just like archaeologists study our ancient leftovers to learn about our ancestors. The stuff on the moon gives us insights about those incredible lunar missions. Some things they left had done their job, like the pole for the flag or the camera they used to broadcast those steps on the moon. Even the tools astronauts used to collect samples were left because they had more precious cargo to bring back: moon rocks. When it comes to the current state of all these items, scientists are not entirely sure. We do know that NASA's Moon Observer has spotted some of their shadows. They're still up there. The official gear was built to resist, so it might behave a bit better. But those personal items? They've probably seen better days.
That's it for today. So hey, if you pacified your curiosity,